Good evening, everyone. Good evening. But Vishnu Ajit, sir, notes not yet uploaded, sir. Is it not uploaded till now? Kindly respond. Uploaded. Actually, I've spoken with him already. It is uploaded, it seems. Kindly Vishnu Ajit, check it. Everyone is saying that it is uploaded. Right, okay. Right. Let us complete the earlier homework questions. By the time other people will join, then we can move to the actual topic. An electronic voltmeter consisting of a full wave precision rectifier. What is it? Here, it is full wave rectifier. Yugasri, it is uploaded. Kindly check it. Everyone is saying that it is uploaded. Can you check it? Right. Okay, right. Here, average circuit gives correct RMS value for square wave input. So what is the value now? Many people asked in the yesterday's class, sir, if I want to calibrate the device for square wave or some other waveforms, is it possible or not? I told you possible. But generally, for sinusoidal waveform, the corresponding calibration will be there, I told you. Okay, but it is given for which one? Square wave calibration. So for square wave, the corresponding input the calibration is correct. Its reading for 2 volts peak to peak sinusoidal input will be, what is the value? 2 volts peak to peak. Okay, right. Now the point here is, what is the input waveform? Sinusoidal, right? Input waveform is sinusoidal. This is a sine wave. What is the value? 2 volts peak to peak. Here to here, 2 volts. So therefore, this is 1 volt. This is minus 1 volt. Total value is 2 volt. This is VI. VI. Clear? Right. This is given to rectifier. This is given to rectifier. What is that? Full wave rectifier. Therefore, half a cycle and half a cycle conducted. Right? This is V naught rectifier output. What is its magnitude? 1 volt as it is. Saumitri Balbhadra Prasad. Yes, yes. Yeah. I'll give the number and you can ask him, no problem. But he will upload as soon as possible only. Here, this is omega t. This is also omega t. Okay. This is given to which one? PMMC, right? This is given to PMMC. Therefore, PMMC reads its average value. PMMC reads its average value. What is that? V average. Okay. Or PMMC response also we can say. Okay, I can write PMMC response. Response for average value. What is V average value? Vm by pi. Many people are doing this mistake. Vm by pi. So therefore, second option. But actually, this is full wave. So answer is 2 Vm by pi. What is V maximum? 2 by pi. Okay. PMMC response for 2 by pi value. But this PMMC calibrated for which waveform? Square wave. So calibration is for square wave. Therefore, the instrument, whatever the PMMC instrument is there, this is the average scale. Average scale means the linear scale PMMC general scale, I can say. So this is the average scale. Okay. And what is the RMS scale here? Can you concentrate? RMS scale. Now tell me, in the square wave input or in the for the square waves, what is the average and RMS relation? Same. So therefore, what we can write now? Square wave, right? VRMS is equal to V average. So therefore, V average into 1 is equal to, what is that? VRMS. So therefore here, 1 into V average is equal to VRMS. Why? This is not calibrated for sine wave. This is calibrated for square wave. But given is sine. Now tell me, therefore, PMMC reads, PMMC reads which value? Average value into which value? V average into 1, because it is calibrated for this value. Sir, what is V average? 2 by pi. 2 by pi into 1. So therefore answer is 2 by pi ohms. Clear? Very simple question. One student already solved and sent me also. But other people, I don't know whether you solved it or not. No need to send me. No need to send me. But if you're done, that's okay. Right? Anyway, right? I'll solve like this and you can verify. Now, next question. A rectifier type instrument uses a bridge rectifier and has its scale calibrated in terms of RMS values of a sine wave. Right? So what is the calibration here? Calibration for RMS values of sine wave. It indicates a voltage of 2.22 volt. It indicates voltage of 2.22 volt when measuring a voltage of triangular wave. Right? Estimate the peak RMS values of the applied voltage. Also calculate the error. Actually, this question and what are the question we have done in the yesterday's class, right? Both are same only. Only value is different. I told you sawtooth waveform question. Is there no? Now here I'm giving triangular wave. Both are similar because Vm by root 3 here, sawtooth also Vm by root 3 only. RMS value. That's it. How many of you done for this? 8. Yes, Abhijit. V peak 4 volt, VRMS 2.3. Error is minus 3.8. Correct. Sahil Singh, VRMS is exactly 2. Not exactly 2. 2.330 something will be there. Have you done? Come on. Yes. Sunil Wagmer, kindly check it. VRMS is 2.3. VM is 2, you are saying. Maximum value is less than RMS. Is it possible? Come on. Other people? Mukul Jagtap. Okay. Different answer you are given. Kindly check it. Error. Those who sent me, I have seen the error and I told it is correct. Error value minus 3.87. Mukul Jagtap, I told you error value, but other values kindly verify. Right. Many people are giving that VRMS is 2.3 something, V maximum is 4, and percentage error is minus 3.8 something. Mukul Japta, you send the answer. I have seen only error. Error is correct. Other values. Let us verify now. Other people, you have given that VM is 1.11, VRMS is 2.22 by root 3. This is given by one student. This is given by many students. Right? Which are correct? You tell me. Vishnuji, triangle means triangle only. There is no question of even or odd signal. Triangle means just triangle signal. That's it. Come on, those who are not done, just at least try now. Come on. All of you are given error is minus 3.8% only. Yes. But these two are given by different people. And Soundarya has given 1.65. New answer. Come on. Can you respond? Right. Let us verify which is correct. Right. See, what is a form factor? What is a form factor? Yeah, correction factor. Full wave rectifier sine wave. So therefore, form factor is 1.11. Clear? It indicates a voltage of 2.22 volt. So it is indicating 2.2 volt means what is the value? VRMS is equal to, what is it? 2.22. It is indicated 1.11 into V average. 1.11 into V average. Am I clear? Right. Okay. Right. See, what is it? This is the instrument. Here it is 1.11 into V average indicated as 2.22. So what is V average value now? 2 value. So therefore here we can write V average as which value? 2 volt. Okay. But which is given what is it? What is it? Triangular wave is given. So therefore, what is it? Triangular. Triangular wave. Okay. V average is 2 volt of the triangular wave. So what is the V maximum value? V average is equal to Vm by 2 for triangle. So therefore, Vm is equal to which value? 2 into V average. So therefore, 4 volt. This is one answer. Clear? If Vm is there, what is the VRMS value? VRMS is equal to Vm by root 3. 4 by root 3, you'll be getting approximately 2.309 volt. Clear? Right? One student has given the answer like 2.22 by root 3. VRMS 2.22 by root 3. No, yeah. VRMS, this is indicated value, not the true value. It is indicated value. Clear? Mukul Jagtap, is it clear, guy? Yeah. But error is correct. Whatever the thing you are given, error is correct only. So what is error formula? Percentage error equal to V measured minus V true by V true into 100. What is V measured? The indicated value. This is measured value. Measured value, or we can say shown value. Okay, 2.22 minus. What is the true RMS value? 2.309. 2.309 by 2.309 into 100. Those who are not done, just kindly calculate this and tell me what value you are getting. So minus 3.8, 5 or 8 for something. So these are the yesterday's homework question answers. Right? Now let us come back to the topic. Digital voltmeters. We are discussing about 3.5 digit DVM, right? Three and a half digit DVM. Kindly concentrate here. I gave the introduction of 3.5 digit DVM, right? Now, just I'm brushing up here. First one, 3 full digits will be there. I gave you already 3 full digits, right? 3 full digits, nothing but what do you mean by full digit? 0, 1, 2, so on up to 9. Okay. For this, what we have to use? 3 decade counters, yeah, mod 10 counters, all I told you. Okay. Right. So what is the second one now? Right here, half a digit. And I gave you that, just I'm brushing up half a digit. So what is half a digit? The half a digit indicates 0 or 1. So 0 and 1, not or, 0 and 1. If a digit is designed to allow 0 and 1, then the digit is called as half a digit. Okay. For this purpose, what we have to use here, I told you, toggle flip-flop. Toggle flip-flop. And what is the advantage of this half a digit? What I told you, range is extended. Range is extended. Range is extended. Clear? Right. Now, the point here is, in this, After extension of range, right? How the entire system will be there and what is the logic in this total detail we are going to take now. Here I told you already, what is it? 3.5 means, what is it here? Simply 0, 0, 0, 0. 3.5 means 3 full digits, 1 half digit, totally 4. Okay, right. Now kindly concentrate. In the first step, what will happen? 4 zeros, right? Sorry, 4 zeros to 3 zeros 1. This is called as first step. This is called as first step. Clear? Okay. Now, sir, if it is keep on going, kindly concentrate. Yesterday I gave you only some introduction, but I'm elaborately explaining. Sir, once it reaches to 0,999, once it reaches to 0,999, now, sir, after this, does it go back to 0,000 like that reset option? No. Why? Means here this 9 becomes 0. Why? 10. So that carry will drive the second counter. So second counter 9 plus 1, 10, 0. Again 9 plus 1, 10. Right? Now 0 becomes 1. 0 becomes 1. So this is nothing but I'm writing clearly half a digit is there. No, half a digit is switched on. Half a digit is switched on. Actually, there is no on off button like switch on, switch off like that will not be there. But generally, the half a digit is activated, means the toggle flip flop is there. No, that will be activated. And then it will continue 1 0 0 1 like that. It is keep on going 1 9 9 9 for example. Okay, full digit 0 to 9. Check it here, 0 to 9, 0 to 9, 0 to 9, all are full digits. Okay, happy. Here only 0 and 1, right? Okay, so after this 9 plus 1 10, 9 plus 1 10, 9 plus 1 10. But here 1 plus 1 2, don't write, it is a toggle flip-flop. 1 is there, again input is given, 1 becomes 0. 1 becomes 0. So therefore, what we can write here? 2000 counts. 2000 counts. This I'm writing as 2 into 10 power 3 counts. 2 into 10 power 3 counts. Clear? So this is the total introduction regarding 3.5 digit DVM. Okay, sir. In this, how many full scale counts are there? Full scale counts. How many full scale counts are there here? 2000. Okay. This can be written as, what is it? 2 into 10 cube. Now what I'm writing, here very, very important point here is, kindly concentrate. Sir, this 2 I'm naming as extension factor. This 2 I'm naming as extension factor. Sir, what do you mean by extension factor? Range is being extended. Compared to which one? Compared to which one? 3-digit DVM. Therefore, our topic is 3-digit DVM to 3.5 digit DVM. 3-digit DVM to 3.5 means 3-digit 1 into 10 power 3. 3.5 digit 2 into 10 power 3 means range is extended. Therefore, the 2 is called as extension factor, right? The important question is, in 3.5 digit DVM, the extension factor is dash. What is it? 2. Clear? Right? This is the simple introduction. Okay. Now let us go to figure now. So what will be the corresponding diagram here? Kindly consider, very, very, very important here. Sir, I'm taking now 3.5 digit picture. Kindly concentrate. Here, what is there? Right? Clock pulses. Right? 1 decade counter, 2nd decade counter, 3rd decade counter, and a 4th one, but it is not decade counter. That is a toggle flip-flop. Kindly concentrate. Toggle flip-flop. Here, mod 10 counter. You can say mod 10 counter, no problem. Here, carry pulse will be driving this again and again like this. Okay. Now how many counters are there means 4 we can say. Mod 2 counter also we can take. We can say 0 and 1 like that. Sir, again, what is the output from this? Undoubtedly, output will be in terms of which one? BCD form only. The counter will be giving the output in terms of BCD form. Clear? Okay, this is BCD code. Okay, now, sir, here this BCD code is being converted into this BCD code is being converted into which one? 7 segment code. I told you the same concept, but only small logic is there. What is this? 7447 IC. 7447 IC. Right? This is being converted into which one? 7 segment code. Okay, right. Sir, here in this 7 segment code, so how many paths will be there? 4 paths will be there now. So far we have only 3 paths, but now 4 paths will be there. Like this. Okay. 7 segment code. 7 segment code. Okay. But be clear, sir. Very, very important. 7 segments like this. Sir, 0 to 9, all numbers here also. 7 segments, nothing but 7 LEDs we can say. Here, 7 LEDs. But here, even though it is 7 segment code, I am showing like this only. Right? And we need to show like this only. Center LED will be there. No, that center LED will be always deactivated. Why? Means this is the digit designed only for either 0 or 1. 0 means like this will be there. Right? The center LED not required. 1 means only like this. Again, center LED is not required. That's why even though it is a 7 segment code, this center line should not be indicated. Then only the opposite person can understand that you know the topic, you know the subject. If you're writing like this, okay, blindly you're following. But as it is a 7 segment code, 7 segments should be there. But this segment is always deactivated mode. Why? Our topic is which topic here? 3.5 digit. 3.5 means in this MSB side, leftmost side, 0 or 1 only. 0 means kindly concentrate. 0 means only like this. 1 means only like this. Right? If you want to have 2, the number will be like this. Means 7 center segment is required. 3 center segment is required. 4 center segment like that. 0 and 1 means center segment is not required. That's why symbolically representation is without this center line. Clear? Okay. Now, sir, here decimal point will be there here. Decimal point will be there here. Decimal point will also be there here. But my question is, sir, can we keep decimal point here or not? Everyone I'm asking the question. Respond. Can we keep decimal point here or not? Everyone respond. Can we or we should not? Yes, no, 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 yes. No, we should not. No, there is only 3 range switch. We should not, as it can, since it is extending range, we can put the decimal point should not be there. Okay. Yes or no, yes or no, people are giving. Right. See, Ashish Raj and Pratyush Punyapu, what is my question? What is your answer? I asked only decimal point is possible or not. If it is yes, I'll explain. If it is no, I will explain. That is what the point. Right. Manish Kumar Bhagat, correct explanation. Right. Gokul Shyam, kindly be clear with the topic. Right. Imtiaz Pasha, very nice, very nice. Yugasri, correct. Okay, Bhavya, no means yes, correct only. No decimal point. Yes, many people are giving that. Yes, no. Kindly concentrate here. Few people are giving the irrelevant answer like 100 word, 3000 watt as decimal point is possible or not. Decimal point we should not keep. Why? Kindly concentrate. Sir, what is the name of this dot? Decimal. Deci. Deci means, what do you mean by deci? Deci means 0 to 9. Deci means 0 to 9. But this digit is given, designed only for which one here? Only for 0 and 1, not 2, 3, 4, 5, 6, not there. So that's why decimal point means it is a point at which 0 to 9 numbers are allowed. At which 0 to 9 numbers are allowed. Simply, if I say that 3 point, if I'm saying some percentage or some marks, etc. If I keep like this 3 point, do you say that don't write more than 3, don't write more than 4, etc.? No, that is my wish. I can write 0.9 also, 0.8 also, 0.7 also. That is the meaning of decimal. That is the meaning of deci. Deci means simply 0 to 9, 10 numbers. But our topic is 0 and 1 only. That's why decimal point should not be placed, and actually speaking should not be allowed technically. Don't think like manufacturer is not keeping account to his interest, or I am not keeping account to my interest. Not like that. According to the concept, I'm saying that this decimal point is not to be allowed. So that's why decimal point should not be there. That is the reason why now the question is coming, sir, even in the 3.5 digit DVM, how many switches internally will be there? How many switch positions will be there internally? Means 3 only. But one student gave the answer like, sir, there are 3 switches, therefore no decimal point. Not like that, yeah, not like that. Simply, as the decimal point is not allowed, as the decimal point is not allowed, there is no switch here. As the decimal point is allowed, switch will be there. As the decimal point is allowed, switch will be there. As the decimal point is allowed, switch will be there. That is what the actual point. So therefore, even in the 3.5 digit, automatically 3 switches only will be there. Only 3 switches will be there. Clear? Is it clear, guys? So therefore, what we can say here, this is A, B, C, and this is 5 volt. Now, I'm asking the question, kindly concentrate on the statement, English statement, very, very important. Sir, as there are 3 switches, we are not keeping the decimal point, first statement, right? As there is not possible to have the decimal point, we are having the 3 switches, which is correct. Everyone, kindly answer, which is correct? Second statement is correct. Yes, correct. Right. See, as there is no decimal point allowed according to the concept, the 3 switches only placed. Don't think like manufacturer is keeping 3 switch only. That's why I'm not getting this decimal point. Not like that. He should not keep the 4th switch. Why? Decimal point is not allowed. Now tell me, here 3 switches are there, means in the range selector switch also 3 only should be there. Why? Here ABC, here ABC should be matched. Therefore, and how many resistance are possible? 3 only. So that's why the simple logic is either 3 digit or 3.5 digit DVM. How many resistances will be there in the attenuator? 3, R1, R2, R3. How many switch positions will be there in the range selector switch? 3 ABC only. How many internal switches will be there? 3 only ABC. But how many digit paths will be there? 3 full, 1 half. Totally 4 paths will be there. But 4 digits. No, don't say 4 digits. You should say 4-digit places, but 3 full, 1 half a digit. If you say this is a 4-digit device, means it is to be taken as 0 to 9, 0 to 9, 0 to 9, 0 to 9. Then we can say it is 4-digit, but our topic is 3.5. That's why be clear with the terminology. What is that? 3 full, 1 half a digit. 3 full and 1 half a digit. Clear? Right. Already I explained why this decimal point is not allowed. Kindly, just now I explained. Kindly, if any doubt is there, you can watch the video again, you can get it. Right? I explained 2 to 3 times why the decimal point is not allowed. Just now I explained. And proceed for the entire thing. Now tell me, whatever the left side circuit we have taken in the 3-digit DVM, here also same thing will be there or not? Same thing will be there. Only the thing is, here this path will be extra. But after addition of this path, there is no disturbance in this portion at all. Why? 3 switches only, 3 attenuated resistances only. So no problem at all. Clear? Right. So is this getting concept only, or will we get any gate questions, sir? Can you please give clarify? Unknown, unknown. First of all, give me your name first. Then I will answer your question. Unknown, unknown. Is your name unknown, unknown? Right. See, always first I will take the topic, then I will be going for the practice questions and previous gate questions also. Right? You are appearing for the gate exam. Kindly have that point in your mind and think that I should learn the concept first. I should learn the conceptual mathematics first. Then I need to go to the numerical question. That is the way. That is the way. This is what the gate student mindset. Otherwise, very difficult. I'm taking the concept. You're asking that, sir, is it only for concept or questions will be there? Means, what is your question? I'm not understanding. Right? Pulkit Chowdhury, what is 7447 IC? Kindly go to the yesterday's class and kindly verify it. 7447 IC. What is purpose? Everything I told you. Clear? So this is the total discussion, because today's strength is around 300. But yesterday, when I started this 3-digit DVM, almost 30 to 40 people left. That's why I'm saying, I'm instructing, I'm suggesting also. Those who miss the class intentionally and the same topic is repeated in the next class, no one should ask the doubt from the topic. If you are up to 9 o'clock today, 5 to 9, yes, be on the line, then ask the doubts, I'll clarify. Right? By leaving the class like just like that and asking the same questions again and again, it is not acceptable. Kindly try to understand. Because of only 1 or 2 people, I don't want to disturb hundreds of people. Clear? Right? Now, here this is a 3.5-digit DVM. Okay, right. This entire thing intentionally I'm not drawing so that you can understand. Okay, yes, why we have not drawn means same thing will be there, which was taken in the 3-digit DVM. That's what the actual point. Okay, right. Now come back to this. So this is the, what is it? Full scale counts. Now tell me, switch A position. Now come on guys, switch A. Kindly concentrate. When we are keeping the switch at A, kindly concentrate. If you would have understood earlier topic, yes, this topic will be same. Only half a digit is extra. That's it. Only half a digit. When the switch is at A, when the switch is at A. Now tell me, when the switch is at A, what will be there? You are going to keep the switch range selector switch at A. Automatically, this switch will be coming to A. This decimal point will be glowing. So therefore, what is a display? 0.000. Therefore, the display will be 0.000. Clear? Unknowingly also, I'm requesting everyone here, unknowingly also, don't keep the decimal point here. If you are keeping the decimal point at the time of starting here, it becomes full digit. Full digit means 4-digit, nothing but 4-digit DVM. That is the next topic. Okay, so therefore 0.000 is the answer. First point. Okay, after that, what is that first step? 0.001. This we take it as first step. This we take it as first step. Kindly be clear, be clear. Don't get distracted. Just like I said, I told you, no, this entire 15 to 20 minutes or 30 minutes of topic, same thing I'm saying. If you understand this, if you observe this clearly, yes, digital altimeter topic will be over, related to GATE and ESC. Okay, and it is keep on going. What will be there? 0.999. Okay, after that, what will happen now? What is it? Half a digit is switched on. Half a digit is switched on. Then it becomes which value? 1.000. Actually speaking, this was taken in 3 digit. This was the last step. But in this, half a digit is there. Therefore, half a digit is there. It is playing the role. Okay, and then it's continuation. It will go up to which value? It will go up to which value? Simply it is keep on going up to 1.999. 1.999. Again, 0, 0, 0. Clear? Right. Now tell me, how many counts are there? Of course, 2000 counts. How many? 2000 counts. 2 into 10 power 3 counts. 2 into 10 power 3 counts. Clear? Right. Now tell me, total thing, whatever I'm writing here, all those are some type of questions only. Once we start the question, you can understand. So what is it? First of all, how many full scale counts are there? Even the switch is kept at A position. 2000 only. Yes, full scale counts are 2000. It can be written as 2 into 10 power 3. 2 is called as extension factor. There 1000 counts, 1000 into 2, 2000 counts. So therefore, yes, 2 is nothing but extension factor. 2 is nothing but extension factor. Clear? Okay, next. Very, very important. Kindly, those who are on the line, be clear. Whatever the 2 lines I'm going to write, very, 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 very important. Based on this, numerical question is there. Conceptual question is also there. Numerical question, 2 marks question, very, 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 very popular in GATE, electrical, GATE instrumentation, ESC, electrical, very, very popular. Not only this, any competitive examination, that model is very popular. And a conceptual question is, yes, generally asked. Kindly concentrate. Sir, in this, what is the minimum value measurable? Now tell me, in this, what is the minimum value measurable? Come on. What is the minimum value measurable? Right? Sir, 0.000 means operation is not yet started. 0.001 is the starting value. Therefore, minimum value is 0.001 volt. 0.001 volt. Very nice, very nice. All of you have given correct answer. This can be written as 1 millivolt. Common sense here. This can be written as 1 millivolt. Okay, right. Next, sir, what is the resolution value in this? Resolution means what I told you. Smallest measurable input change. What is the smallest value you are able to measure? What is the smallest value you are able to measure? You are able to measure the smallest value as which one? This one only, that is 0.001 volt. It can be written as 1 millivolt. It can be written as 1 millivolt. Now, very, very important point. Kindly concentrate. Sir, in the 3-digit DVM, in the 3-digit yesterday's topic, 3-digit DVM, switch A position gives 1 millivolt resolution only. 3.5-digit DVM also giving the resolution of 1 millivolt only at switch A position. 3-digit DVM, switch A. 3.5-digit DVM, switch A. Resolution is same or different here? Resolution is same. Therefore, with the addition of half a digit, concentrate, with the addition of half a digit, resolution will not be disturbed. Resolution will not be disturbed with the addition of half a digit. That's why half a digit does not play any role. Half a digit does not play any role in defining the resolution, because if it is there or not there, the resolution will be same. Switch A 3-digit to switch A 3.5 digit, same notation. So that's why very, very, very important point here is, what is it? Resolution. Resolution will not be disturbed. We can say resolution is the same, or resolution will be same. Clear? I'm going to prove it again and again. Kindly concentrate. Sir, what is the count value? Step value. What is it? Each step consists of 0.001 volt, mean 1 milli only. Therefore, 1 millivolt per step, or 1 millivolt per count. 1 millivolt per step, or 1 millivolt per count. Right? Now, sir, how many counts are there totally? 2000 counts are there. Very, very important. This step also very important. 2000 counts. What is the count value? 1 millivolt per count. 1 millivolt per count. So if you multiply this, you will be getting 2 volts. You will be getting 2 volt. Now tell me, sir, this 2 volts is extended range or normal range? Extend only. Why? You are taking this number into picture, means after the switching on of half a digit, whatever the value is coming, that's what 1.999 almost equal to 2 volt. 1.999 almost equal to 2 volt. Therefore, this 2 volt is which value? Extended range. Extended range. Okay. Now I'm modifying this as 2 into 1 volt. 2 into 1. Sir, what is this 2? This is extension factor. 2 is extension factor. 1 volt is which one? Normal range. 1 volt, nothing but normal range. Yes, in the 3 digit switch A position give that 1 volt range of operation. But if you are adding half a digit to the 3 digit device, it becomes 3.5 digit. So therefore, the range becomes 1 volt to 2. The range becomes, what is it? Range will be changing from 1 volt to 2 volt. Yes, 1 volt is a normal, 2 volt is the extension voltage, or nothing but 2 is the extension factor. Now tell me, with this entire discussion, after addition of half a digit, resolution does not disturb. Okay, does not get disturbed, but range is extended. 1 volt was there, it becomes 2 volt. Therefore, I gave you already, what is it here? Simply range is extended, but resolution will be same. Therefore, very important point is half a digit and resolution, both are independent. Half a digit is there or not there, resolution will be same. Corresponding switch positions, A to A, B to B, C to C, or to compare. But if half a digit is placed, range will be extended. Yes, half a digit is placed, range is extended. That's what the point. Clear? Now I'm asking the question, is this first step is clear or not? Don't worry about the switch B, switch C. I will come to that. Is it clear or not? Come on, guys. Those who attended the class yesterday till 8:30, they can understand well. Those who left the class, no one can help you. Come on. Right. Now switch B, same discussion. For more clarity, I'm writing each and every step. Otherwise, switch B homework, switch C homework. That's very simple, but I'm writing everything so that if anyone is having still doubts, those doubts can be clarified. Now, so switch B means where will be the switch position? Switch B means you will be placing the switch to B. So automatically it will be moving to B. Moving to B means this ray, that this decimal point will be glowing. So therefore, what we can say now here, 0, 0.00, 0.00. Therefore, first step, what is it? 0.01, of course, voltage. It is keep on going up to which value? 09.99 normal. What is it? Extension range, nothing but simply half a digit is not getting activated so far. Now it is getting activated. So far it not got activated. So therefore what we can say, half a digit is switched on. Half a digit is switched on. Clear? Right. Now 10.00 volt. It will be continued. Otherwise, this was the last digit topic, 9.99 only. That was there in the 3-digit, but it is 3.5. Extension is there. So therefore, we'll be going for this one. Okay, after that, it is keep on going. It will be coming up to 19.99 volt. After that, 0, 0, 0. Kindly don't write like this. I'm requesting you to don't write like this because it is toggle flip-flop. It is a 3.5 device, not the 4, not something else device. It is 3.5, either 0 or 1. Okay, either 0 should be there or 1 should be there. That is 0 and 1 we can say. Therefore, still how many? 2000 counts and 2 into 10 power 3 counts. 2 into 10 power 3 counts. Clear? Right now, after that, same discussion. Full scale counts. How many? 2000. That can be written as 2 into 10 power 3. Okay. After that, minimum value. Now tell me, what is the minimum value? What is the minimum value? 0.01. 0.01 volt. It can be written as 10 milli. Okay. Right. Sir, here. What is the resolution value? Resolution is nothing but smallest measurable input change. What is that? Smallest measurable input change. What is the smallest measurable? This only. So therefore, 0.01 volt, that is nothing but 10 millivolt. Just go back to the yesterday's topic. Sir, 3-digit DVM, switch B position, we have got 10 millivolt only resolution. Here also same. That's why half a digit does not disturb the resolution. Half a digit does not disturb the resolution. And few people are doing like this. Sir, 0.01. No, I will erase these two because value is not there. Mathematically okay, but in my measurements point of view, wrong. Why? If you are writing like this, what does it mean? It is a 2-digit DVM, but our topic is 3.5 digit. That's why each and every digit must be represented, whether it is 0 or non-zero, it should be represented. Now, so what is the count? What is the count? 10 millivolt per step or 10 millivolt per count. 10 millivolt per step or 10 millivolt per count. Right? Now, how many counts are there? 2000 counts are there. Totally 2000 counts into. What is the count value? 10 millivolt per count. So therefore, it becomes which value? Tell me, it becomes which value? 20 volt. But what is this? This is extended range. Why? 20 automatically after extension only. Why? 19.99 after extension. So therefore 20 after extension only. It can be written as 2 into 10 volt as usual. 2 is extension factor, 10 is the normal range. Clear? At least now, if anyone is having small doubt, at least now is it clear? Come on, guys. Right now, switch is at C position. Switch is at C. Right? Can you write from your side? Can you write this? Switch C. Can you write? Right. Anku Dole, why not 20 into 1? Come on here. What is our extension factor? Already gave you in the basic point. Extension factor is 2. So that's why I'm dividing this 20 as 2 into 10. Suppose if you're writing 20 into 1, can you say 20 is the extension? No. Can you say 1 is the normal range? No. Switch B is not the normal range 1. Switch B, normal range is 10. So that's why based on the concept only I'm dividing 2 into 10. Anku Dole clear? Extension factor base we have to take. Yes, very good, very good, very good, very good. Very nice. No, I'm don't type all the things and don't waste the time. No need to worry. Just if you're writing, that's okay. People may be facing the problem in typing the entire thing. No need to type. But Sai Charan, you have given each and every value clearly. Very good. Murali, correct. Tarun, correct. Gurudatta Behra, correct. Already written, sir. Rajit Tyagi, very nice. Right, Navin Sai, correct. Right, Sangeeta, correct. Okay, now let me complete this. Switch C. 0, 0, 0.0 volt. First step. 0, 0, 0.1 volt. What is it? After having first step, this one. Keep on going up to, right? 1. So 0.99 volt. Here, half a digit. Here, half a digit is switched on. Half a digit is switched on. Right, correct. Here, what is that? 100.0 volt, 100 volt, and it will be continued up to 199.9 volt. Finally, 000.0 volt, 000.0 volt. Clear? Then what we can say here, 2000 counts. 2000 counts. It can be written as usual 2 into 10 power 3. Okay, right. Now same thing. Can you write all these things? Everyone, those who are on the line, can you write all these things? Unknown. Completely wrong. Kindly concentrate. If you are interested in the gate and if you are interested in the class, kindly see the screen clearly. Unknown. I told you to change the name. And unknown is still giving that 0.0, sir. It will be going up to 99.9. It is which device? 1, 2, 3, 3 digit. You're talking about 3 digit. But our topic is 3.5. Kindly wake up. Kindly wake up. Kindly. Right. Right. Sahil Singh, can we say total 6,000 counts? How can you say? That is for each step you have to say. You cannot operate all the steps at a time and you should not say 6,000 counts. Did I say yesterday 3,000 counts? No, 1,000 counts only. Why? Switch A 1,000 counts, switch B 1,000, switch C 1,000 in the 3 digit. Now switch A 2,000, switch B 2,000, switch C 2,000. But all the things cannot be operated at a time. So therefore, full scale counts are still 2,000 only. We cannot say 6,000. We should not say 6,000. Clear? Right. So what will be the final step I'm giving? 200 volt. Which range? Extended range. Okay. This can be written as 2 into 100 volt. 2 is extension factor. 100 is normal range. Clear? So this is a total discussion regarding entire topic 3.5. That's why I spent a lot of time in the 3-digit so that you can understand 3.5-digit device very simply. Okay, now conclusion. Very, very, very important. Resolution formula. Resolution formula. Sir, what is a resolution formula? Yesterday we have taken resolution R is equal to, what is it? 1 by 1 into 10 power n into scale range. I have written okay, range. But sir, here what you have to take? 1 into 10 power n, yeah, 2 into 10 power n, which must be taken according to the concept what we have taken so far. Can you respond? Should it be 1 into 10 power n or 2 into 10 power n? Right. Allah Navin Sai, correct. Very good. That all I told. Yes, very nice. Right. 2 into 10 power, 2 into 10 power n. So therefore, what we have to write here? 2 into 10 power n into, sir, 2 into 10 power means 2000. 2000 are extension based counts or normal count means extension. That's why we should say extended range. Extended range. Suppose if you write 1 into 10 power n, no problem. You should write normal range. Both are correct only based on this point. Many of the cases, I can say 99% of the people are getting confused in the GATE exam and taking the, getting the wrong answer. That wrong answer will be there in the exam. Will be there in the exam. So kindly be clear. What is it? If you want to write normal range, you take normal count. If you want to write extended range, take the extension factor. Both will be same only. Suppose, okay, where, what is n, guys? What is n? N is number of, what you have to write? Number of digits we have to write or number of full digits we have to write? Where n is number of digits or number of full digits? Can anyone? Where n is number of digits or number of full digits? Right? Dinesh Rampur, if you are writing digits, it is with respect to half a digit also, but we are defining resolution. All I told you, half a digit does not play any role in definition of resolution. Both are independent, I told you. But in the resolution, do you include this? No way. Suppose, right? As many people told that number of digits, okay. How many digits are there? 3 full, 1 half, 4. So if I write 10 power 4, how many counts will be there? 1 by 2 into 10 power 4 means 2 into 10 power 4 means 20,000. 20,000 counts, have you got it? No, 2000 counts only. That is the reason why here n must be 3 only. N must be 3 means simply you have to take only full digits, not the total digit. Therefore, number of full digits only to be taken. Number of full digits only to be taken. Very nice. Of course, only 1 or 2 persons gave the total digit, but other people gave the same answer. This is the resolution formula. Clear? Right. Now, before taking the entire questions and all, just simple question I'm asking, simple point I'm asking, kindly concentrate here. Right, sir. On 1 volt range, on 1 volt range, right? 1 volt range you are operating, right? Can you give 1.5 volt in which device? 3.5 device. Very, very important point. Kindly understand my statement. 3.5 digit device I'm discussing. 1 volt range I'm operating. Can I give 1.5 volt for proper display or not? Tell me. Can I give 1.5 volt for proper display or not? Can I give 1.5 volt for proper display? Okay. Few people are giving yes, few people are giving no. Yes, no, yes, no, yes, no. Yes, Gopal Jimin, correct. Mukul Jagtap, correct. Right. Very nice. Very simple, yeah. This is the competitive examination model terminology. They don't give extended range. 1 volt means immediately by the concept you should get the point. Like 1 volt means 1 into 2. So range of operation is up to 2. 2 volts range. 2 volts range means it will allow up to 1.999. So why can't we give 1.5? Yes, we can give. But few people got confused. That is a genuine doubt. No problem. It's not your mistake. That is genuine doubt. Why, sir? 1 volt. You are discussing about 1 volt. 1.5 is more than. Yes, okay. But our topic is 3.5. 3.5 means 1 volt range is there. Means into 2 will be there. Why? 3.5 without extension we cannot operate. 3.5 itself indicates extension will be there. 3.5 itself indicates extension will be there. Therefore, if he is asking about 1 volt, concentrate. If he is asking about 1 volt, automatically in your mind you have to calculate. Okay, 1 volt, 3.5 device means 2 is the extension. 1 into 2. Yes, 2 volts. Yes, this is possible. Are you clear? But happy, many people give the correct answer. Clear? Right. Now, sir, 10 volt range I'm operating. Can I give 11.75 volt in 3.5 device? Everyone tell me the answer for this. 3.5 only. My question is for 3.5. Vinita, you are giving no. Dinesh, no need to worry. Extended, no need to give. Yes, correct. Yes, yes, yes. Except one student, everyone gave that. Yes, as the answer. Yes. What do you mean by that? 10 volt range means half a digit device. No, automatically 10 volt means 20 should be there. Why? Sir, here switch B. 10 volt means do you operate 10 separately? No, extension will be there. Why? Already digit is included. Half a digit is included. Therefore, 10 volt means indirectly that is for 20 volt. That is for 20 volt. So therefore, is it possible? Yes, possible. Clear? And display is also properly available. Clear? Right. Now, next question. Sir, in 3-digit DVM, in 3-digit DVM, what is that? In 3-digit DVM on 10 volt range, can I give 11.75 volt? In 3-digit DVM on 10 volt range, can I give 11.75? Come on. No, no, no. Very good. Very good. Yes, correct. Yes, many people give the correct answer. Right. So this is the total discussion regarding entire 3 and 3.5 digit DV. Clear? Right. Next, one more formula directly there, that is sensitivity formula. It is not by derivation or something. This is just by conceptual explanation. Sensitivity S is equal to full scale minimum into resolution. Full scale minimum into resolution. This is the formula of resolution. Full scale minimum into resolution. Sir, what do you mean by full scale minimum? Everyone knows that resolution. Yes, okay. But what do you mean by full scale minimum? What do you mean by full scale minimum? That we have to concentrate. Right. What do you mean full scale minimum? Sir, if you are going for 3.5 device, what is it? If you are going for 3.5 device, how many ranges are possible? 1 volt means 2 volt. 10 volt means 20 volt. 100 volt means 200 volt. So out of all these, which is the lowest or minimum full scale value? Yes, 1 volt. Sir, in order to define sensitivity, we should take lowest full scale or highest full scale. Means lowest full scale only. Why? Sensitivity itself indicates the corresponding thing related to which one? Lowest values response. Lowest values or smallest values response means yes, correspondingly low. That's what, based on this concept, this formula. But don't worry, I have not missed anything. You also did not miss anything. Like, sir, how it is coming? This is by concept only we are giving, not by derivation, nothing. Only conceptual based formula directly. This is the total discussion regarding 3.5 digit DVM. 3.5 digit DVM. Clear? Right. Morally correct. Now, so based on this, just not there, but sometime you may be getting the questions. So therefore, I'm taking 4-digit DVM. 4-digit DVM. And here, 4.5 digit DVM. 4.5 digit DVM. Okay, right, sir. What is that? Very, very simple. 4-digit means 4 zeros as usual. 0001. But it will not end here. If it is ended here, what is that? That is 3.5. But our system will be continued up to 4 nines and again 000. Clear? Therefore, what we can say now simply 10,000 counts. 10,000 counts, nothing but 1 into 10 power 4 counts. Very, very simple. If you understand 3-digit, 4-digit will be exactly similar. Right. Murali, 2 volts is not the minimum. 2 volts is there means normal range. 1 volt is also possible. So 1 is minimum. Right. Now tell me here, 4.5 means 4 full digits. Concentrate. 1 half a digit. Okay. And like this will be there. It is keep on going. What will be there now? 0, 4 nines will be there. Then half a digit will be switched on. I'm writing here half a digit is switched on. Half a digit is switched on. Then it will be going to this number. Okay. Again, it is continued up to 19999. Finally, 000 will be there. So this will be equal to which one? 20,000 counts. This is equal to 2 into 10 power 4 counts. In this also extension 2 only. So therefore, half a digit is there means automatically extension factor will be 2. That's 20,000 counts. Simple. This is not there, but if you understand 3.5, 4.5 will be same, 5.5 will be same. But before going to the question, now tell me, can we keep the decimal point here? Yes. Can we keep the decimal point? Yes. Can we keep the decimal point? Yes. But can we keep the decimal point here or not? Tell me. Whatever the arrow mark I have given now, at this point, decimal point is allowed or not? Everyone respond. Apratim Pandey, that depends on the device. 3.5 will be there, 4.5 will be there. They will mention 3.5 related multimeter, yeah, 4.5 related multimeter, they will mention. Right, very good. Yes, allowed. Why? This is 4-digit here. Concentrate. Up to 9 we are allowing. So therefore here 4 decimal points are allowed. In this 4 decimal point here allowed. Why? 0 to 9 full digit. 0 to 9 full digit. 0 to 9 full digit. 0 to 9. Therefore 4-digit means 4 full digits. Okay. Now last question. Sir, here can we allow the decimal point here or not? Can we allow the decimal point here or not? Respond. Very good, very good. Not allowed. Why? Why it is not allowed? This is 0 or 1 only. 0 or 1 means decimal point is not allowed. 0 or 1 means decimal point is not allowed. Clear? Right? Now, this is the total topic related to the digital altimeter. Somewhat lengthy topic compared to other. Right. Now, let us start the questions. The digital altimeter. For simple conceptual question. First, I will be taking all 1 mark questions. Then we'll be going for 2 marks model. Yes, what is the answer? I told you, no, generally always we use dual slope integrating type. So therefore this dual slope integrating type ADC. Right? Now, next question. Come on, tell me the answer. Right. See, the resolution of 3.5 digit altimeter is 0.001. True or false? True. Assertion is true. Right. Now people are getting confused. Sir, how can you say this is true? Be clear. So switch A resolution is this. Correct. Right? Switch B resolution is this. Switch C resolution is something 100 milli. But in this question, nothing is mentioned. So therefore, whatever the given value is possible or not, switch A it is possible. But no need to mention switch A only. No, that is correct only because at least one of the switch positions it is possible. Yes, A is true. What about reason? Addition of half a digit to a digital altimeter increases the range. Correct. But reason is the correct explanation of assertion or not? Reason is giving the correct explanation for first statement, that is assertion or not? Tell me. Reason is giving the correct explanation or not? Not giving. Why? In the reason, half a digit is there. In the assertion, resolution is there. Both are independent. So therefore, A and R are independent. A and I are independent. Means R is not the correct explanation for assertion. In this also questions are possible. Clear? Right, next. Next question. In a digital altimeter, overranging implies that. In a digital altimeter, overranging implies that. Overranging means extension of range. Overranging means extension of range. Simple logic. That question. What is that? Half a digit is switched on. Half a digit is switched on. Why? Next 4 digits are to be switched on. Not necessary. Half a digit is switched off. No. An overrange indicator starts glowing. No. Half a digit is switched on. Correct. Right? Next. Answer this properly. A digital voltmeter has 4.5-digit display. The 1 volt range can read up to. The 1 volt range can read up to. The 1 volt range can read up to. Sangeeta, overranging means not out of range. Overranging means extension of range. Not normal English meaning of overrange. Meaning is extension. Tell me, 1 volt range can read up to. Yes, I know many people are giving option C. Many people are giving option C, but you are forgetting half a digit. You are forgetting half a digit. Be clear, half a digit is there. 1 volt range means kindly be clear. I already told you just now. 4.5 digit means 1 volt range is the normal, but that indicates 2 volts range. So therefore, what will be the number here? 1.9999 volt. But many people give the option C. Many people give the option C. But answer is option D. Why? 1 volt range means 2 volts will be there automatically. Why? Switch A position. 1 volt range, not stop. 1 volt is a normal, but it is extended automatically with the half a digit. Therefore, 2 volt. Same logic, 2 is the extension factor. Clear? Or still any doubt is there with this? Come on. Is it clear? Right, next. Very simple question here. A digital voltmeter has a readout range from 0 to 9999 counts. So therefore, how many counts are there? How many counts are there? 0 to 9999 counts means how many counts? 10,000 counts. 10,000 counts. Right? When the full scale reading is 9.999. So full scale reading is 9.999 means what is the range? Range is how much? 10 volt. Am I clear? Right? So therefore, resolution is equal to range, right? 10 volt, right? Counts, 10,000 counts over. What is that? Simply 1 millivolt. 1 millivolt. Nayan Sanjay Kalaskar, 10 millivolt you have given. Kindly check it. How do you get 10 milli? Mukul Jagtab, 100 millivolt you have given. Kindly check it. Check it. You will be getting 10 by 10,000 means 1 millivolt. Right? Now let me take one more question. Direct question. I'm giving 1 minute of time. Try this. What is the answer? Option B, option D, option C, different answers. Kindly concentrate. Sensitivity formula. Full scale minimum, nothing but lowest full scale range into resolution. Just now I give the formula. What is it? Full scale minimum, lowest full scale is 100 millivolt. Resolution is 0.0001. Right? So therefore, 100 two zeros cancelled. 0.01 millivolt. 0.01 millivolt. So option is B. Okay, multiply properly. Multiply properly. How do you get 10 milli? Got it? Dinesh Rampur, please cross check previous problem. Which one? This one? Yeah, Dinesh, what is your doubt? Dinesh, what is your doubt? Please cross check previous problem you have given. What is your doubt in this previous question? Answer is 10 milli. Why 10 milli? Dinesh, why 10 milli? One zero cancelled. 1/1000. I hope 1/1000 is 1 milli, not 10 milli. Why 100/10,000? Dinesh, why 100? Why 100? This is V10 volt. Can you see the question? See the question. Aishwarya Vishwanath, 0.001 is in volt. No, it is no unit. So therefore, volt into no unit. Volt will be there. Right? Dinesh, I hope clear. It is clear. Right. Yeah, if you are getting confused with volt to millivolt conversion, I can't do anything. So kindly be perfect in the smallest, simplest mathematics. Vikrant, right? Next. Make it fast. Bhavana, resolution has no unit. That depends on the given data I told you in the electrical measurements. Given unit is there, you'd keep it, no problem. Right. Pitambar Prakash Chaudhary. Sir, if the lowest full scale is not given in the question, you're asking the question like this. Concentrate. 10 volt, 5 ohm, right? 5 ohm, 2.5, 2.5. I'm asking you to find out R total. You're asking the question like, sir, in the given question, If the resistance values are not given, how do you find out the total resistance? This is what the meaning of your question, right? Without giving the resistances value like this, can I ask you to find out R total? Come on. Prakash Chaudhary, are you getting my point? Prakash Chaudhary, are you getting my point? Right? In the question, if you want to answer, if you need to answer, they have to give the question, right? They will ask the question compulsory. Okay, right. Now, here, what is that? 4.5 digit DVM. Okay, on 10 volts range, very, very simple. Resolution is equal to 1 by 1 into 10 power 4 into 10 volt. Why? 4.5, 4 full. So therefore, 10 power full digits, 10 power 4 into range is 10. So automatically 1 millivolt. Direct answer. Right. Alluri Sai Sri, you have given B option. Why? Again, you people are getting confused with this conversion from milli to volt. So kindly be clear. Right now, let me take one more question. Right. So far, I have taken 1 mark model questions. Now I'm taking 2 marks model questions. Kindly concentrate. One second. 2 marks model question. This is the given data. Right? Very, very important model. Right? Concentrate here. Sir, don't write. I will solve this. I will solve this. Don't write. Here. A 3.5 digit digital voltmeter has an internal reference. Sir, internal reference means full scale value, or we can say scale range. Scale range. Clear? Right. 200 millivolt is given. What is a device type? 3.5. Full scale value 200 milli. Full scale count he is asking, and resolution he is asking. Don't try. I will do. Sir, what is the full scale counts? No doubt at all. The full scale counts automatically 2000 by 3.5 device 00002 1,999. So how many counts will be there? 2000. There is no second thought at all. Directly answer is this. That's why I gave you switch A, switch B, switch C. Everywhere 2000, 2000. So full scale counts are 2000. Okay. But unfortunately, 2 options are there with 2000. So therefore, we need to do second part compulsory. What is that? Resolution. Very simple. Resolution is equal to, very, very important point. Concentrate. 1 by 1 into 10 power n into normal range. Or I can say 1 by 2 into 10 power n into extended range. 2 formula I gave you. Here, now I'm using one of the notations. So this 200 millivolt, concentrate. Full scale value is 200 millivolt is given. How can we write this in terms of extension factor? Full scale value, always scale range must be divided into extension factor and what is that? Normal range. So therefore 2 into 100 millivolt. 2 into 100 milli. 2 is extension factor. 100 millivolt is normal. So therefore, sir, I'm taking normal count because extension factor I'm not taking. So therefore, I can say simply because 3.5, no, 1 into 10 power 3 into range. What is that? 1 by 1 into 10 power 3. Range is 100 millivolt. So directly 100 by 1000. What is that? 100 by 1000 means 0.1. So therefore, answer is 0.1 millivolt. This is what the answer. Doubt might be there in this question. If any doubt is there, kindly let me know. I will clarify. If this is clear, one more 2 marks model is there. One more 2 marks model is there. Clear, guys? Right? Manikumar Basani, 2 into 10 power 4. No, sir. It is here 3.5. What is that? 10 power 3 only. In the earlier question, if you want to write 2 into 10 power 4, you should write 20 volt. What I told you, extension. Otherwise, normal. If any doubt is there, I'll go back and I'll show that resolution formula. Normal range, extended range. So what is it? 1 volt, 10 volt, 100 volt, 1000 volt. That is normal. 1 into 2, 2 volt, 10 into 2, 20 volt, 100 into 2, 200 volt. All those are extended ranges. So that's why, be clear, extended means multiple of 2. So 2 into 1, 2 into 10, 2 into 100, 2 into 1000, like that will be. That is called as extended. So therefore, in this previous question, he has given only 10 volt. 10 means normal. So I have taken normal. Right? Here, normal. Extended is given. I have converted into normal. I have substituted normal. 0.1 milli. Therefore, answer is which one? Third option. Option C. Right. Sir, full scale value is different from maximum value, sir. Kindly be clear with the question. Unknown. Kindly be clear with the question. Right. Half it is Akshay. Half a digit always action factor will be 2 only. And we have proved it. No, yeah. Every step by step we have proved it. Sunil, if you use extended range, then multiply. Yeah, that's what. If you want to take this one, if you want to take that, you need to take this one. Answer will be same. 200 by 2000 or 100 by 1000. Both will be same. That's why take normal to normal, extended to extended. But don't mismatch the combination. Right. So how to know it is normal or extended? Just now I told you, Arshad Ali, while I was explaining, you are typing. That's why you missed it. 1, 10, 100, 1000, 10,000, 1 lakh. If the things are like this, normal. I think you might have not concentrated at this point. Here, I told you 2 into 100, 2 into 10. Here, 2 into 1. All these are normal. 2 is extension. So therefore, 220, 200, 2000, those are extended. 1, 10, 100, 1000 are normal. That's why while I'm explaining, while I'm speaking, you should not type anything, then 100% topic will be clear. But while I'm explaining you, if you're typing, definitely you'll be missing. Right. Clear? But still people are asking that, sir, I am getting 1 milli. If you are getting 1 milli after completion of BTech and you are writing the gate, no one will help you. Sir, I am getting 1 millivolt, means I can't do anything. If you are getting 1 millivolt for this, I can't do anything. Okay, don't say this to your mathematics faculty, I'm requesting. Right. Sunil Wagmer, sir, if there is 300, then it is extended. 300 is possible. 300 means 3 into 100. 3 is the extension factor, but our syllabus is 3.5 only. 2 is the extension, 3 is extension, 4 is extension. That is not there. But device, it is possible. But account our syllabus, yes, half a digit is there, only 2 is the extension. Clear? Sai Charan. So the ranges of DVMs are considered as normal range. Actually, if half a digit is not there, there is no question of normal or extended, only range, simply range. That's why in the yesterday's class, 3 digit, no extension factor, simply range. Don't say normal or something, simply range. But in the 3.5, 4.5, normal will be there, extended will be there. That's what the point. Right? Okay, now I'm taking one more question to conclude this entire chapter. After the class, kindly go through all these questions and topics. Then you will get more and more clarity. Now what we are doing, you're typing the things while I'm explaining. That's why you're missing the points. Right. One more question. Right. Here. 100% I'm giving the guarantee, right? 100% giving the guarantee. Confusion will be generally there in this model. This is 2 marks question, very, very popular in GATE exam for electrical, for instrumentation, ESC exam for electrical people, and all test series examinations of any institute. This model question is very, very, very popular. That's why no one should write anything. No one should write anything until I complete this. Then you will understand each and every point. Sir, 4.5 digit DVM is there. 4.5 digit DVM, right? Error specifications of 0.2% reading, actually comma, plus 10 counts means error is with respect to two things. One is 0.2% of reading and other part of the error is with respect to the 10 counts. So therefore, two errors means error is because of two things, 0.2% of reading and 10 counts. What is the meaning? I'll tell you. And if a DC voltage of 100 volt means red means what is a true value given to that, etc. And 200 volt full scale. What is a full scale? 200. I'm saying again, sir, half a digit. 200. Immediately to understand that, okay, half a digit means 2 is the extension. 200 is given means 2 into 100. That you have to get it first. Otherwise, 100% wrong answer you will get. Wrong answer will be there in 4 options. Definitely, you will be losing the marks. Definitely. That's why kindly be clear. If you understand this model, yes, only they will be changing the values, but this model is very, very popular. The maximum error that can be expressed in the reading. So error is because of two things. He's asking the total error. What is the value? Okay, kindly let me explain. No one should write anything. No one should get distracted. Sahil Singh, kindly don't ask any question from now onwards. Right? All I told you, don't type anything. Don't type anything until I complete. If you are missing the thing, I can't do anything there. After explanation, I'll give the time, then you can ask me any number of questions, no need to worry. Right? It may be feeling differently for you if I say that, but this is the way of getting the subject. Once opposite person is speaking, listen first. Listening capability is very, 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 very important in getting the subject. I'm speaking something, you're typing something, missing. Next topic again, missing. Next topic, continuously doubts will be. That's why while I'm speaking, not only me, any faculty, the moment the faculty started speaking and writing, you should stop typing. You should stop asking the doubts. Once he is giving the time, then you can ask the doubt. Clear? Otherwise, you will be missing. I don't be the loser. You will be the loser. Okay, right. Kindly concentrate. Sir, 4.5 digit DVM. Okay, happy. Error is, what is it? 0.2% of reading. 0.2% of reading. And 10 counts. 0.2% of reading and 10 counts. Okay, next. True value. T indicates true, A means some value. What is given? 100 volt is given. And full scale value, what is it? 200 volt. Immediately, I'm requesting everyone, you should observe this one, 2 into 100. Whether writing or not, that is different, but you should observe this one. Clear? This is a given data. What he is asking? What is the total error? Okay, right. Now, sir, error is because of reading. Right? Now, I'm taking two parts of this solution. What is that? First part, 0.2% of the given reading. 0.2% of the given reading. 0.2% of what is a given reading? What is the given reading here? 100 volt. So therefore, 0.2% of 100 volt. 0.2% of 100 volt. Therefore, 0.2 by 100 into 100 volt. Therefore, what is the value? 0.2 volt. Of course, error means plus or minus. Error will be always either positive or negative. Either positive or negative. Okay, right. Second part of the error. Second part of the error. What is that? 10 counts. So error is due to 10 counts. Sir, if you want to get 10 counts, you should get one count value. What is one count? I told you. One count value is, be clear, one count value is, check it here. Sir, resolution is 1 milli. Count value is also 1 milli. So both are same or different? Yes. Why? Smallest measurable input changes one step only. Therefore, that is a resolution. That is a count. Therefore, in order to get count value, what we need to calculate? Resolution we need to calculate. Therefore, resolution value or one count value, both are same. So therefore, I'm taking now. What is that? Resolution. Now here, kindly don't type anything, but let me complete first, because in this small logic is there. Resolution 1 by 10 power 4. Why? 4 and half. 4 and half. So therefore, 1 by 10 power 4. By mistake, people are writing like this. Sir, full scale is given 200. Okay, let me write this. Let me write this first. 200. What will be the value? 200 by 10,000 means you will be getting which value? 0.02. 0.02 volt. Clear? Okay. Therefore, resolution means one count is equal to, what is the value? 0.02 volt. But how many counts of error is there? 10 counts of error is there. So therefore, 10 counts is equal to 10 into 0.02 volt. What is it? 0.2 volt. Okay, so this is one error. This is one more error we have got. But I'll tell you what is the problem. I'll tell you. By doing this, now tell me, therefore, total error. Therefore, total error equal to plus or minus. First error is 0.2. Second error is also 0.2 volt. What is the value? Plus or minus 0.4 volt. Okay, right. After that, sir, percentage error equal to, what is the formula? Error with respect to true value. True value is 100 volt into percentage. Nothing but error value by 100. What is the true value? Therefore, you are going to get plus or minus 0.4%. Plus or minus 0.4%. By doing this, sir, option is 4. Fourth option, D option. Many people, not only many, 90% of the people are solving like this only. But unfortunate thing is, in few test series, in few normal textbook, local textbooks also, this is given as the correct answer. People are feeling like, yes, this answer is correct. But is it correct, guys? No. Where we have mistaken? Kindly concentrate. We have mistaken here. Where? Concentrate. Sir, resolution, you have taken which one? Normal counts, but you have taken extended range and normal counts. Is it acceptable? Definitely no. That's why 2 into 100, this is normal, this is extension factor. So that's why what you have to take here, you should take here one only. You should take here one only. Otherwise, if you take 2 here, you should take 2 here. That's what the normal to normal, extended to extended. So therefore, I'm taking normally, normal range. What's the value now? 0.01. So therefore, one value, one count is equal to which value? One count equal to 0.01. 10 counts is equal to 0.1 volt. Now, this 0.1 plus earlier 0.2. 0.1 plus earlier 0.2. If we add, you'll be getting 0.3. 0.3, you'll be getting 0.3%. This is the correct answer. This is the correct answer. See, even after saying this, I'll tell you some practical issue what happened earlier. Kindly concentrate. I gave you which is wrong, and I told you why it is wrong. Finally, I have corrected with the correct formula. I have taken the same thing. right? Same model I gave, same model I gave in the test series question, but values are changed, right? Values are changed, and you are having the access to write our ACE Academy test series or XYZ Institute test series. You can write it. That's your wish. Yes or no? One student last, but 1 year on 2019 it happened. Kindly concentrate. Just I'm giving one practical thing. What happened? One student has written some other institute test series, some other institute. I don't know something. Is he written? And I gave what is it? 0.3 notation. Okay, but they gave 0.4% answer. 0.4% answer. Okay, they have one student has written the test series. They solve something, etc. They have the solution in the entire solution manual with 0.4%. What that student message me in my WhatsApp number, simply they have posted the question. What the question is, they have posted the question along with that, sir, actually this is the answer. Which is the answer? 0.4% is the answer, but you are wrong. You gave the wrong answer. Nothing is given, simply, sir, you are wrong. They have given 0.4, but you are told 0.3. Without any justification, he messages simply like, sir, you are wrong. Now tell me, 0.4 is wrong or 0.3 is wrong? By the concept, you need to answer. Respond kindly. Which is correct? 0.3 is correct or 0.4 is correct? Generally in my class, every time, wherever this type of logic is there, I will give the wrong procedure, what every student generally do, and then I will correct it so that it should be injected into your mind clearly. But even after that, even if the student told that like this, now tell me, which is correct? 0.3 is correct or 0.4? Yeah, 0.3 only correct. I gave the proof with the explanation also already here. Already here, I gave the, what is it? Normal to normal, extended to extended. But if you take like this, is it acceptable? Yeah. No. Counts are normal, means 1000 counts you are taking, but range is 2 volt, 20 volt, 200 volt. Is it acceptable? No. And if you are taking like this, is it acceptable? No. That is the reason why I'm requesting everyone, be clear with this model. If you're taking extended, no problem. Extended counts. If you're taking normal, no problem. Normal counts. This is 2 marks model. Very, 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 very important model. Very, very, very important model. Now you can ask any doubt in this question. Tell me, any doubt in this question? Come on, guys. What does error due to 10 count means? That only I told you. 10 counts error means actually error is 0.1. He has not given 0.1. He has not given 0.1. He has given error is due to. Error is due to 10 counts. He has given 10 counts means 10 counts value. Concentrate here. Here 1, 2, 3, 4, 10 counts. If you take 1, 2, 3, 4, 5, etc. This total 10 count. So 10th count, whatever the value is there, that is the error he mentioned clearly. But instead of giving the value directly, he has given 10 counts error. Means first steps, first count, second count, third count, fourth count, etc. 10th count will be there no, 0.010 like that will be there no. That is the value of error he has asked. But he has not given the value directly. We need to calculate. That's why 10th count we have taken. One count value is 10th count is this. Therefore, according to the given data, 0.1 volt is the error due to this second part. 0.2 volt is the error due to first part, and we need to add them. That's what the point. Right. Rohit Yam. Right. Very good question. I'm coming to that only. Right. Sai Charan Reddy, that's what I clarified just now. Instead of giving 0.1 volt, he has given that 10 counts. One count value is 0.01, 10 counts value is 0.1. To confuse you, you are saying that, so I did not understand why he has given. To confuse you, that is given. Okay, right. Next one, a very good question. I am coming to that only before concluding. Sir, actually 100 volt is red. 100 volt is red. Yes, but how can you take true value? I told this in the electrical measurements clearly so many times for the people who attended my class. But other people, those who are not attended, yes, you are getting the doubt correct. That's I want to clarify. Sir, 100 volts is red. Okay, that implies measured only. But based on the given data, if true value is required, but true value is not mentioned, if it is mentioned as a red value, you should treat that as the true value. This is the measurement theory. That's why I've taken directly 100 as a true value. Suppose measured value is given, as red value is given, and a true value is given separately in the data. Is red value is measured value, true value is anyway actual value. That is a terminology. So keep this point in mind. No need to worry. In the electrical measurement, so many questions are also there. No need to worry. But those who attended my measurements, electrical measurement class, yes, 100 volts red. Sometimes we need to take it as a true value according to the given data. According to the given data, we need to take it. That's why I have taken. Simple. Nothing is missed. No need to worry. Right. Mahesh, I told you. Rohit, yes, I clarified your doubt. Clear, guys? Right. Based on the same topic, I'm giving one question as a homework. Kindly come with the answer in the tomorrow's class. Okay, after that, I'll be taking the next chapter. Same model I'm giving. Don't worry, exactly similar model I'm giving. But a device I have changed. Just I'm explaining. 3.5. Okay. 0.5% of reading, comma, 5 counts. I give 10 counts here, 5 counts. Meter reads 2 milli, what you take? It has a true value only. And full scale value 20 milli. Everything is same. Only values are different. Device capacity is different. That's it. Can you do it? Can you let me know first whether you can or not? Can you? Right. Very good. Very good. Very good. So this is the total discussion regarding digital voltmeter. Right? Right. I'm going to next topic, that is Q meter. Third chapter, very simple. Q meter, very small topic I can say. But I'm taking as a chapter wise. Q meter, very simple point. After that, I'll give the break. After the break, I'll continue. Sir, Q meter is for which one? Quality factor determination. Quality factor is determined with the corresponding Q meter. Okay, so in order to define the quality factor, which condition is required? Everyone, I think network theory is completed for many people, even though it is not done in ACE Academy, but you know about network theory basics. What is that? Quality factor can be determined under resonance condition. Therefore, in order to define the quality factor, in order to determine the quality factor, resonance condition is required. That's why the Q meter is designed such that it will operate based on the resonance. That too, this is designed to work with the series resonance principle. Series resonance principle. So working principle of Q meter is series resonance. Working principle of Q meter is series resonance. After that, don't worry. For many people, network theory is not done. I know. So what is series resonance? I will give the brush up. What I require for my measurement. Then I'll continue my Q meter. Very simplest chapter. Okay. I'm stopping now. Take the break. 15 to 20 minutes of time and come back. We'll continue. Right, come back. See, this is the error meaning. It may be given as plus or minus n or just plus, no problem, common value, because anyway we are making error as plus or minus error value, so no problem at all. Is it plus or minus? No need to worry, simple value. Okay, right, coming back. So what is series resonance? Just I'm giving the formula. I'm not explaining the entire series resonance that is in the network theory, but what is I require, what is the topic I required, I'm revising that entire thing. So what is series resonance formula? First of all, series resonance formula is XL is equal to XC, right? If this inductive reactance is equal to capacitive reactance, then the circuit is said to be under resonance condition, first point. And what is XL? 2 pi FL, XC 1 by 2 pi FC. Therefore, what we can say, F is equal to 1 by 2 pi root LC is a formula. This is the conditional resonance. That's why I'm writing FR. Therefore, FR formula is resonant frequency. FR formula is 1 by 2 pi root LC. This entire thing is network theory part, but without saying that you study in the network theory like that, I'm not saying. Simply I'm brushing up all the basic points. I'm noting down all the points whichever I require for my Q meter. Okay, after that, sir, XL is equal to XC. If I multiply with I on both sides, what will be there? I into XL VL, I into XC VC, I into XL VL, I into XC VC, right? Either XL equal to XC or VL equal to VC, both are called as conditions for resonance. Okay, and what is the supply voltage? VI is equal to V supply voltage equal to general formula. I hope everyone knows this, right? RLC series circuit will be there. VR square, VL difference of VC square whole root. This is the general formula of supply voltage in RLC series circuit. In RLC series circuit, this is the general formula. But under resonance condition, as VL is equal to VC, as VL equal to VC, what we can say, VL, VC both are same, resultant is 0. Therefore, what we can say, VI is equal to Vs is equal to VR. Sir, whatever the supply voltage we are giving, that will be appeared across only resistor. That's why what we can say, L and C effects are both are equal and opposite, both will be nullified. Therefore, circuit acts as which circuit? Just resistive circuit. Circuit acts as just resistive circuit. That is called as resonance circuit, series resonance. Under series resonance condition, RLC circuit acts as resistive circuit. Why? With the proof I'm giving. But so what is the meaning of XLXC? In depth you study in the network theory. But what is resonance meaning I'm taking? Under resonance, what happens I'm taking. Okay. Under resonance condition, we define the quality factor. Under resonance condition, we define the quality factor. So what is a quality factor? Q is equal to omega L by R. Q is equal to omega L by R is equal to 1 by omega R into C. 1 by omega R into C. Okay, right, sir. This is a general formula for quality factor. Sir, what is omega L? XL. Omega L means simply 2 pi FL, that is omega 2 pi F into L, X suffix L by R. 1 by omega C is XC by R. Why? Check it here. XC means 1 by 2 pi FC. 2 pi f is omega. So 1 by omega into c is nothing but xc. I'm multiplying with I and dividing with I. Here also multiplying and dividing with I. Sir, what is I into XL? VL. What is I into R? VR. I into XC? VC. I into R? VR. Nothing but voltage across resistance. Sir, voltage across resistance, we can call that as supply voltage or input voltage. Why? Under series resonance condition, the supply voltage is equal to voltage across the resistance. Therefore, what we can say, Q is equal to VL by VR or VC by VR. We can call this as, or we can write this as VL by VI is equal to VC by VI or VS. So therefore we can write, therefore VL is equal to VC is equal to quality factor times the supply voltage. Quality factor times the supply voltage. Sir, this is called as, those who attended the network theory, those who completed the network theory, kindly tell me what is this called? This condition is called as which condition? Come on. Bharati, yes, kindly check it. Is it current magnification or voltage magnification? See, it is not resonance condition here. Topic is resonance condition only. I am asking about this. This is called as voltage magnification, or we can say voltage amplification also. Voltage magnification or voltage amplification. Why? Under resonance condition, voltage across inductor or voltage across capacitor is magnified by the quality factor times, means more than the supply voltage, means quality factor times the supply voltage, the voltage drop will be available across the voltage across inductor and capacitor. Okay, why I have given all these means, this is the last point in your network theory topic, but this is the first and foremost point in our Q meter. That's why I have taken the entire introduction regarding this. Okay, this voltage magnification only we are using in our entire Q meter. Very simplest topic. Q meter is very small chapter. Okay, now with this entire basic, now I'm starting the Q meter. What is it? Quality factor determination. So how do we determine the quality factor? Let us see now. Here, sir, in this Q meter, first I'm drawing the circuit diagram. Here, one socket will be there. This is generally called as socket, right? Whatever the coil is there with us, that coil is having simply RL notation. This is unknown coil, R coil, L coil, unknown coil. Okay, means in this socket, we need to keep our unknown coil for which we are going to determine, the quality factor. Are you clear? Suppose this is one coil with me. Okay, I would like to measure, I would like to determine quality factor. Where you have to keep this? We have to keep this in the corresponding socket which is available. Okay, after that, sir, in the circuit, we are having one capacitance. This is variable capacitance or tuning capacitance C. Tuning capacitance or variable capacitance C. Okay, and here this is the path available for supply. But here in this entire thing, the supply is not given directly. The supply is not given directly to the structure. Supply is not given directly to the structure. So what will be there? Let us see now. Concentrate. Sir, here one small resistance is placed. For which purpose, I'll tell you. And across this resistance, right, oscillator will be connected. What is this? This is oscillator. This is oscillator. Okay, this oscillator will generate the frequency of oscillations, nothing but this will be giving the variable frequency. So therefore, yes, we can write here variable frequency, means we can vary the frequency. Okay, now the AC input to this entire Q meter is not given directly, with one variable facility given, that is what oscillator. With the oscillator, the corresponding frequency of oscillations will be given, that will be dropped across the R, and this voltage is measured with one voltmeter, and that voltage is acting as the input voltage to the entire Q meter structure. This entire Q meter is getting the input voltage across this one. Actually speaking, without this entire thing, concentrate, without this entire thing, directly we can connect one supply voltage, that is VI. But we are having one facility with this entire oscillator. What is it? I'll tell you. Clear? And whatever the voltage is dropped across the capacitor, that is also measured by one voltmeter. This I'm taking as VC. That's it. This is what the entire circuit of the Q meter. Total circuit of Q meter. Okay. Now, what is there? Kindly concentrate. Actually, our Q meter is this. Okay. This is unknown element. We are connecting from outside when we wanted to measure the quality factor of the coil. Yes, we wanted to measure quality factor of this coil. Okay. My point here is, sir, you place this coil. Okay. Now, so how do you determine, how do you observe the resonance condition is occurred? Means kindly concentrate. Everyone remember carefully. Follow this point. Vary the tuning capacitance, vary the frequency, both together or one after the other as you wish. Both together or one after the other as you wish. Okay. By varying the available, what is it? Tuning capacitance or variable capacitance, and what is it? Frequency of oscillations. Observe the resonance condition. What you have to do? We need to observe the resonance condition. And under resonance condition, yes, we can get the quality factor directly. But my question is, sir, how do you understand that resonance condition took place while you're varying capacitance and frequency, one after the other or together, etc.? How do you observe that resonance condition is occurred? Everyone respond. How do you observe that resonance condition took place? Respond, guys. If you understand this point, total mathematical discussion only after this. Yes. Alan, VA equal to VC. Kindly concentrate. Devika, VA equal to VC. Is it VA equal to VC condition? Is it VA equal to VC? Kaleponil, VC equal to VA. Is it? VC equal to 0. Is it? Before typing the answer, of course, keyboard is there. It is free of cost typing. That is, I know. But before typing, kindly think of it. Kindly think of it. Before typing, kindly think of it. Come on. Right? Few people gave the answer. Right. Very, very simple. tuning capacitance frequency match with oscillator frequency, then resonance will occur. What is this, Imtiaz Basha? What, Imtiaz Basha, what is this? No? Right. Okay, I'm coming now. See, vary the variable capacitance and frequency of oscillations until the resonance occurs. How do you understand the resonance occurs? Means concentrate. The voltage across the capacitor will be magnified. Voltage across the capacitor will be magnified. Isn't that only I told you? Voltage magnification, voltage amplification means you keep on varying, you keep on varying. Voltage across capacitor is 5, again varying 5.5, again varying 6, like that. Suddenly it will be increased to 50 or 100, like that. That is called as voltage amplification. Very, 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 very important point in the network theory, that is resonance condition. That's why while you are varying the tuning capacitance and corresponding frequency of oscillation, you need to observe the voltage amplification. Once the voltage amplification is occurred, stop varying the parameters. Then note down the parameters of Vi and Vc. Simply what we can say, Q is equal to Vc by Vi. But this Vc is not every value of Vc. No, the Vc value must be taken under magnified condition. If you keep on varying the two parameters, voltage across the capacitor will be suddenly amplified to some high value. That is happened only under resonance condition. Therefore, it is suddenly magnified. Stop varying that and note down the Vc at that point. Note down the Vi at that point. Simply Vc by Vi is quality factor. It is very, very simple. That's why I told you this chapter is very, very simple. That's why my topic is just 5 minutes topic. That's why you need to have, what is that, quality factor basics, resonance condition basics. That's why I brushed up what I require. Therefore, voltage magnification is playing the role. Therefore, you need to vary the elements until the voltage amplification takes place. Once it takes place, stop varying that. Yes, note down the values correspondingly. Q equal to Vc by V over. Very, very simple. This is what the total circuit diagram and operation of the Q meter. Okay, now let us start the mathematical explanation. Conceptual explanation is very, very simple, but mathematical explanation is very, very, very important. Concentrate. Sir, first of all, what is the true value of quality factor? Whatever the coil you are connecting, what is the true value of quality factor? Simply omega L coil by R coil. Omega L coil by R coil. Okay, that is nothing but 1 by omega R coil into corresponding C. One is RL combination, one is RC combination formula. Okay, right. This is Q true value. Sir, what is the Q measured value? Q obtained value. Q determined value from the circuit. Kindly don't say Vc by Vi. Vc by Vi is correct only. But I want to write the formula in terms of elements. Now tell me, Q measured means Q measured with the circuit you are measuring, without the circuit you are measuring, circuit device we can say. That's why measured value is circuit frequency. Inductance in the circuit, check it. Inductance in the circuit is only L coil. No other inductance is there, only L coil. But sir, resistance in the entire circuit. Now tell me, this R and this R, both are coming in series or parallel? This R and this R, both are coming in series. Therefore, the total resistance in the circuit is R plus R coil. Now the people are getting confused. Sir, why are you taking like this? Means very simple. Sir, this is the Q value which is determined from the circuit. So therefore, this is the value obtained from the circuit when R is included in the circuit or R is excluded in the circuit. Means when R is included in the circuit. When R is included in the circuit. So therefore, what we can say here, R plus R coil must be considered from the circuit. Okay. Now, sir, 1 by circuit frequency omega only, circuit resistance R plus R coil. But very, 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 very important point is, Sir, what is the capacitance in the circuit? What is the capacitance in the circuit? Generally, people are saying that, sir, simply see. No. If you are keeping one element from external side, why? This is the device available. This is the RL coil I'm keeping. So we are keeping from outside. If you are keeping from outside, means definitely outside capacitance, that is called as stray capacitance, will be definitely affecting the internal capacitance. That stray capacitance I'm drawing here like this. That stray capacitance I'm drawing here like this. This is the capacitance, that is called as simply CD, distributed capacitance or self capacitance of the coil, which is coming from the outside. Why? We are keeping the coil from outside. Why? This is the device. This is my unknown coil. Something else is your unknown coil. Yes, you are keeping that unknown coil here. Therefore, from external side, definitely you take any device, external field effect will be there. Internally capacitance is there, outside capacitance effect will be there, definitely. Yes, CD, that is distributed capacitance. Yeah, we can say self capacitance of the coil. But the problem here is this CD and this C will be acting in which, or will be in which connection? Electrical people, you should not give the wrong answer because power system is being completed, it seems. Now tell me, external capacitance will be in series with the internal capacitance or in parallel with the internal capacitance in general? Tell me. Very good. Pragati, Mukul, Sachin, Pratyush. Right. Other people? Abhijit, kindly check it. Jayesh Gupta. Okay, Jayesh Gupta, correct. Vaishnavi, check it. Connection is series, but we represent it in parallel. Navin Sai. Okay. Bhavana, series. Okay. Bimal into Swain. Neither series nor parallel. Then which connection? Neither series nor parallel. Then which connection? No, that is in parallel. That is in parallel. But don't think like, sir, this is coming in series, but we take in parallel. No, yeah, I have drawn with a dotted line. If I draw with this thick line, okay, this capacitance is coming in series, etc. But this is to be drawn with a dotted line because this is not the element related capacitance. This is the external effect. External effect. Of course, this is CD or with respect to external element called unknown coil. But actually speaking, this is distributed throughout the circuit like this. This is distributed throughout the circuit from this point to this point completely. That's why always be clear with one terminology. External capacitance must be considered in parallel with the internal capacitance. You might have taken transmission line, right? Line to ground capacitance. All will be in parallel series, parallel only. And insulator case also, yes, ground capacitance coming in parallel. So therefore, always the external capacitance should be, will be treated as parallel only, parallel only. But I know this is general confusion, sir, but you are drawing in series. No, I'm not drawing in series. This is only dotted line I'm showing such that it is not the actual element which is there in the circuit. No, it is acting from outside. Always our theory says that external capacitance must be taken in parallel with the tuning capacitance. So therefore, now tell me, what is the capacitance in the circuit now? C plus CD. C plus CD. Now tell me, if you compare these two, measured value is not equal to true value, error will be there. Measured value is not equal to true value, error will be there definitely. That is what our device, error will be there. Error should be there. But our duty is to minimize the error. We cannot eliminate the error, but we can minimize the error. Okay, so therefore, sir, if you compare these two, error is due to which element? Omega L coil same. R coil same, only R. Therefore, if you consider these two, we can say that error is due to the value R. Right? If you consider these two formulae, error is due to the value of R as well as CD. Of course, error is due to R and CD. Okay. Now, first point, sir, QM is not equal to QT. Of course, measured value cannot be equal to true value. Error will be there, and practical scenario means error should be there. Definitely, definitely. Right? Okay. Allah Navin Sai. Sir, C is in parallel with CD. You written C plus CD. Yes. Tell me, parallel combination of capacitors. What is the formula? Come on, don't forget this. Don't forget. C parallel C1 plus C2 plus so on plus Cn. C series. What is it? C1 C2 by C1 plus C2. I'm requesting everyone, being an electrical student, you should not forget this at all. You should not forget this at all. But resistance, reverse. This is the notation for resistance parallel. This is for resistance series. But capacitance is kindly don't forget this. Don't forget this. Okay, right? Next. Sir, QM is not equal to QT. Okay, but QM is less than QT, yeah, greater than QT. Tell me, QM is less than QT or more than QT? Come on. QM is because numerator is same, denominator is more, so less. Here also numerator is same, but denominator is more, so therefore QM is less than QT. Therefore error is negative. In this entire Q meter, error is always negative. Error is always negative. Clear? This is the introduction. Now, in order to have the elaborated explanation, first topic I'm taking. The first topic is error due to. I'm analyzing error due to only R. I'm taking error due to only R. Kindly see the see the heading clearly. Error due to only R. I'm analyzing. So therefore, I'm taking the formula like Q true is equal to omega L coil by R coil. Okay. Q measured is omega L coil by R plus R coil. Okay, I'm taking this for example purpose. Okay, now tell me, already you have taken these two. What is that? QM is less than QT. Error is negative. That is okay. Error is negative. Okay, happy. But my question here is, sir, concentrate here. Concentrate. Sir, QM, QT. QM is less than QT. Okay, happy. But now the point here is, sir, what is the error formula? QM minus QT. What is QM minus QT? What is QM minus QT? Omega L coil by R coil, R plus R coil minus omega L coil by R coil. So therefore I'm taking omega L coil common. Omega L coil common. Okay. 1 by R plus R coil minus 1 by R coil. 1 by R coil. Okay. Now omega into L coil, and here if you simplify this, you'll be getting minus R by R plus R coil into R coil. I'm keeping here into R coil. This is the error formula. Actually, while we are solving the questions, you can do, but complete analysis I'm giving. Error formula. If these two are there, you can calculate, but I'm giving the formula. Okay, sir, I would like to get percentage error. I would like to get percentage error. QM minus QT by QT into 100. Sir, what is QM minus QT? Sir, this is QM minus QT by QT. Check it. QT and this value both are same. So cancel. So therefore, what we are going to get? Minus R by R plus R coil into 100. From now onwards, any question is there in the gate paper like find out the percentage error, means minus R by R plus R coil into 100. Directly you can use the formula and you can get the direct answer. Okay, next one more. notation. I would like to take Qm by Qt. I would like to take Qm by Qt or Qt by Qm, anything, just ratio I'm taking. Qt by Qm or Qm by Qt as you wish. Qt by Qm, for example. What will be there? Qt by Qm. Omega L coil, omega L will be cancelled. So therefore, which is the remaining part? R plus R coil by R coil. So therefore, Q true is equal to Q measured into R coil by R coil 1 plus R by R coil. This is the earlier paper question. Direct answer. Q true is equal to Q measured into dash. This is not given. 4 options you have to choose. This is the error due to only R I'm taking. I'm separating. Already we have taken. Universal formula we have taken. But for easy understanding purpose, I'm separating the terminology. Error due to only R, we have taken this. Clear? Now, second model is error due to only CD I'm taking. Error due to only CD. Error due to only CD. Sir, why are you taking only CD? R plus CD will be there, no? If you want to have that, already gave you R plus CD. You can analyze this, you can take it. But I'm taking separately only CD. Only CD, I'm repeating only CD. Therefore, concentrate here. Sir, Q true equal to 1 by omega R coil into C, true value. What can be written for measured value? Again and again repeating. Still, after repeating so many times, people are asking the same question. Sir, why are you missing that letter, etc.? Kindly concentrate. 1 by omega R coil only I'm writing, right? People are asking that. Sir, actually here R should be there. No, but you are writing only R coil. Why, sir? Kindly see the heading. My task is only due to CD. And people are asking, sir, why are you neglecting R? I am not neglecting R. I am taking error. I am analyzing error due to only CD. Sir, why can't we take both? People are asking. Yes, if you want to take both, already told you. My topic is over. What is it? 1 by omega R coil C, 1 by omega R plus R coil into C plus CD. Use these two, then you will get the error due to R and CD combination. But for easy analysis purpose, I'm separating error due to R, error due to CD. Are you clear with the terminology? Can you respond those who are on the line? Is it clear? Why I'm not taking R means according to my heading, according to our requirement, I'm following this. Clear? Right. Now analyze this. Sir, of course, QM is less than QT only. Error is still negative. That is common. Okay. Now, sir, what is the error formula? QM minus QT. QM minus QT. What is QM minus QT? Simply, I'm taking 1 by omega R coil common. R coil is there. 1 by C plus CD minus 1 by C. Okay. Here, 1 by omega R coil. Okay. C minus C cancel, minus CD. If you simplify, you will get this. C plus CD into C I'm keeping here. This is the error value. Okay, right. Sir, what is the percentage error? The percentage error equal to QM minus QT by QT into 100. QM minus QT by QT into 100. Sir, this is QM minus QT. This is QT. What will be there? 1 by omega R coil C. 1 by omega R coil C will be cancelled. Therefore, remaining part is this. Therefore, minus CD by C plus CD into 100. So this is percentage error. This is percentage error. Okay. After that, same thing I'm taking. Sir, Q true by Q measured. What is that Q true by Q measured? Q true by Q measured. Omega R coil, omega R coil. Therefore, C plus CD by C. So what will be there? C plus CD by C. Q true is equal to Q measured into 1 plus CD by C. This is what the formula. Clear? Simple mathematical analysis I'm giving. Right? Okay. Means with the Q meter result, we can find out error due to R, we can find out error due to CD also. Now the third one is, sir, what is the resonant frequency? What is the resonant frequency formula? Resonant frequency FR is equal to, I already gave you the formula from basics. What is that? Here, 1 by 2 pi root LC. Okay. But in our Q meter, how many capacitances are there? 2. Therefore, 1 by 2 pi root. L means we should write clearly L coil into C plus CD is also there in the figure. So therefore, we should write C plus CD. This is resonant frequency formula. And fourth one is, if you want to calculate inductance of the coil, if you want to find out inductance of the coil, what will be there? From this, you can write inductance of the coil. What is it? 2 pi FR I'm bringing here. 2 pi FR. Okay. Square I'm bringing. Therefore, here you will be having L coil C plus CD. Okay, simple mathematics. Therefore, inductance of the coil is equal to 1 by 2 pi FR. I'm writing as omega R square C plus CD. With this formula, you can get inductance of the coil also. This is the total mathematical analysis from the entire Q meter. That's why I told you this chapter is very, very, very simple and small chapter. What is it? Simply vary the corresponding variable elements, observe the voltage magnification condition at the time, voltage across C, voltage across input side, or voltage across small r. Yes, get the value of Q. But from this, mathematically, how the questions are possible in the competitive examinations means all these formula based. Clear? Clear, guys? Complete mathematics clear or not? Right, now let us have some questions. After that, one more topic is there. We'll take that after the questions. This is the earlier gate question for electrical people. Direct question. Earlier gate question only. The Q meter works on the principle of, direct answer, series resonance. The Q meter works on the principle of series resonance. Right? Next. Right. Answer this. Anyone? Option B, sir. Very simple, direct question. Sir, this is our unknown coil. This is the capacitance. Across that capacitance, how much voltage is there? V naught is there. Yes or no? So V naught is there. So therefore, V naught by VA, direct answer. But this question is very simple. But if you see the options, confused, chance is there for getting confused. V by V naught by like confused. That should be clear. Voltage across the capacitor by supply voltage. Yes. So therefore, what is the answer for this? Quality factor Q is equal to voltage across capacitor by supply voltage. Voltage across capacitor by supply voltage. Clear? Right. Give me the answer. Come on. Right. Many people gave the answer. Is there anyone giving the answer D? Is there anyone? Yes. Ashok Gadipati Raju. Yes, D has given. Okay. Yes, yes. One or two persons will be there who gives generally D option for this question. That is what the main point here. Try to understand the question here. Terminology clearly given here. A Q meter is supplied with an oscillator having. So what is this? Oscillator output voltage. Don't think like output volt means people are observing this. Sir, output voltage means okay, right side, which is the right side capacitor is not like that here. Oscillator output voltage. Sir, oscillator output voltage is which value? Oscillator output voltage is here. Oscillator output voltage is input voltage of our entire Q meter RLC circuit. So therefore, what is the given data? The given data in this is, what is it? VI is 500 millivolt. While testing an unknown inductor, the voltage across the variable capacitor of the Q meter measured by a digital voltmeter, some voltmeter across capacitor obtained as 10 volts. So voltage across capacitor is 10 volt. Therefore, Q is equal to VC by VI 10 by 500 millivolt. Therefore, you are going to get 20 is the answer. Clear? C option. But by mistake, if you take like this, 500 millivolt by 10, you will be getting 0.05. Option, it is there, but this is wrong. Are you clear? Right. Kundrap Murali. Just I'm saying that you are giving the same answer, option D. No, okay, right, right, yes, yes. After my speech, if you are correcting, that's enough. Okay, that's why output of the oscillator is input to the entire Q meter circuit. Come on. Try this. Come on. Anyone? Make it fast. Right. See, this question terminology is somewhat complicated, but if you observe this clearly, very, very simple. Here, kindly concentrate. Each and every word, statement I'm reading, I'm writing the value. A reading of 120 is obtained. So Q is equal to 120 is obtained. When a standard inductor was connected in the circuit of a Q meter and the variable capacitor is adjusted to a value of 300 pico. Therefore, 1 by omega R C1, this C1 value is 300 pico. That's what the point means. Here to here, this entire thing is single line. Okay. After that, very important. A lossless capacitor of unknown value Cx is then connected in parallel with the variable capacitance. What did he do? 1 by omega, already tuning capacitor is there, and unknown capacitance is connected in parallel with the available tuning capacitor. Right? Cx, unknown capacitor is connected with this. Here. And the same reading was obtained. Same reading was obtained. Okay. When the variable capacitor is readjusted to, so I'm taking this as C2, it is readjusted to 200 picofarad. Then the value of Cx. After writing this, it looks very, very, very simple. C1 is 300, C2 is 200. What is Cx value? What is the answer here? Simply 100. But if you don't understand the terminology, parallel is connected, something confused. That's why based on the statement, write the value, you will get it. So therefore, what is it? Cx is equal to 100 picofarad. Clear? But many people gave the answer. Very good. Right, next, one more question. He's asking error. So much of unnecessary data may be there. A coil with a resistance or coil 10 ohm, right? direct measurement mode, etc. Frequency of oscillator 1 megahertz and tuning capacitance 65 picofarad. Then the magnitude of percentage error introduced in measurement of Q. So percentage error is dash when the insertion resistance, means I told you know some resistance is included in the oscillator output side, that is R is equal to 0.02 is given. Direct formula, already gave the derivation of percentage error. Percentage error is minus R by R plus R coil into 100. Yes, directly substituted. Percentage error is minus R by R plus R coil into 100. Now substitute it. Tell me the value. Everyone? Ashish Raj, please do not mark on correct answer. Why? What is the answer? Few people are giving option B, few people are giving option C. You will be getting answer as 0.2%. So option B is the answer. Clear? Direct answer, substitution. That's why I told you this chapter is very simple. Only simple substitutions will be there. Right? Next, one more question. Right. A very low loss coil is tested with a Q meter and the distributed capacitance. In this distributed capacitance, CD is given. What is it? CD is equal to 820 picofarad. Okay. Resonance occurred at angular frequency. He has given that omega R is 10 power 6 radians per second with a capacitance C 9.18 nanofarad. Then find out the inductance of the coil. L coil is dash. Find out the inductance of the coil. Direct substitution. Kindly tell me the answer. What is the formula? L coil is equal to 1 by omega R square C plus CD. Substitute all the values. You'll be getting answer as Henry. You'll be getting answer as 100 micro Henry. So answer here is second option. Right. Apratim Pandey, option D. Right. Kindly check it. Come on. What is the answer here? Option B or option D? Right. Next. Here, so far we have taken inductance calculation, yeah, corresponding error calculation. Now we are going for here determination of or determining the value of CD. What I told you, CD name is distributed capacitance, or we can say self capacitance. Distributed capacitance or self capacitance. Now tell me, how do we determine this distributed or self capacitance? People are saying that, sir, here FR is equal to 1 by 2 pi root L coil C plus CD is there, sir. Okay, but in our hand, which is there? FR is there because we are varying. C is there because we are varying. But L coil from outside means we are keeping the coil. CD is also from outside means in the single equation, generally two are unknown. Suppose if one thing is given, happy. But if two are unknown with the single equation, is it possible to determine? With the single equation, is it possible to determine here? No way. So that's why single equation, two are unknowns. Definitely it is not possible to determine. That's why what is the procedure? Very, very simple. Here, in this two steps I am taking so that I am going to get two equations. If two equations are there, automatically we can get simplification. What is that? Suppose, be clear. Experimental analysis. This is done by experimental analysis. Kindly concentrate. First, concentrate. Vary the capacitance. What is the procedure? First, vary the capacitance and fix it to some value. Vary the capacitance and fix it to some value, that is C1. Okay. And then vary the frequency until the resonance occurs. Vary the frequency until the resonance occurs. That is F1. Okay. Assume that that is simply F1. Okay. Under this condition, what can be written? F1 is equal to 1 by 2 pi root L coil into C1 plus CD. C1 plus CD. Am I clear? Am I clear in this point? What I have? Right? What I have done here? First, I have varied the capacitance and fixed some value. I have varied the capacitance and fixed some value. Clear? After that, I have varied the frequency until the resonance occur. Until the resonance occur. Am I audible now? People are giving that not audible, etc. Am I audible now? Okay, right. Now tell me, I have varied the capacitance C1 and I have varied the frequency until the resonance occurred. Okay, but sir, this is equation 1 only, but still two are unknown. Two are unknown. That's why we are trying to get a second equation. How? Let us see. Very, very, very important. Sir, I am changing the frequency directly such that I am changing the frequency directly such that F2 is equal to N into F1. That is, N must be equal to F2 by F1. F2 is equal to N into F1. So what is the meaning of this? Assume that you have fixed some capacitance. Assume that X picofarad, we don't know something. You varied the frequency, and varied the frequency until the resonance occurred. Assume that at 1 kilohertz resonance occurs. Note these to write the formula. Okay. After getting this, I am changing the frequency directly such that 1 kilohertz is there. No, I am changing the frequency, means I am fixing some other frequency such that relation between these two will be there. That's why n into f1. It may be 2 into 1, 2 kilohertz, 3 into 1, 3 kilohertz, f4 into 1, 4 kilo, or 1 by 2 into 1, 0.5 kilo, like that. Anything. But relation must be there from equation 1 to equation 2. That's why n must be equal to f2 by f1. N must be equal to f2 by f1. Clear? After that, here, now change the capacitance, vary the capacitance until the resonance occurs. Vary the capacitance until the resonance occurs. Now, what is the equation? F2 equal to 1 by 2 pi root L coil into C2 plus CD. C2 plus CD. This is equation 2. Clear? Now tell me, in these two equations, how many unknowns are there? L coil CD, L coil CD. Two unknowns are there. Sir, we are having two equations and we are having two unknowns. So shall we proceed? Can we proceed or not? Yes, we can proceed and we can calculate. Are you clear? I'm repeating the entire statement. Kindly concentrate, those who are on the line. Change the capacitance, fix some value. What is the tuning capacity? We'll fix some value. Then vary the frequency until the resonance occurs and get this equation. After that, change the frequency such that F2 and F1 is related. Change the frequency such that F2 and F1 is related. F2 is equal to N into F1. N is equal to F2 by F1. And vary the capacitance until the resonance occurs. Vary the capacitance until the resonance occurs. That is C2. Then F2 is equal to 1 by 2 pi root L coil C2 plus CD. So two equations are there, two unknowns are there. Yes, we can equate it. Clear? How? Let us proceed now. So here F2 is equal to 1 by 2 pi root L coil C2 plus CD. F1 is equal to 1 by 2 pi root L coil C1 plus CD. We have got it. Now simply F2 by F1, equation 1 by 2 or equation 2. This is equation 2. This is equation 1. I'm taking just 2 by 1 or something. Simply I'm taking equation 2 by equation 1. Okay. What is equation 2 by equation 1? F2 by F1. Okay. 2 by cancelled. 2 by cancelled. So what will be the remaining part? F2 by F1 means, what is it? Root of L coil C1 plus CD by, okay, root of L coil C2 plus CD. After that, F2 by F1 means N. Proceed and tell me CD value. Take 2 minutes of time and tell me the CD equation. Everyone has to give the answer. Come on. Tell me. Simplify and give me the final answer. I have written the F2 equation first, F1 equation later. F2 by F1. F2 by F1. Kindly consider, I have written the second equation first, first equation later. Just idea purpose. Actually, this is there in the earlier page, but for clarity purpose, I kept these two here. Very good, very good. People give the answer. Gautam, kindly check it. Yeah, other people give the correct answer. Priyanka, you have to replace F2 and F1 with respect to N. F2 by F1 is N, I told you. Right. You will be getting the answer as CD equal to C1 C1 minus N square C2 by N square minus 1. This is the formula of CD. C1 minus N square C2 by N square minus 1. Got it? Yes, correct. Or some people might be getting this N square C2 minus C1 by 1 minus N square. Both are same only, no need to worry. So this is the total discussion regarding Q meter concept and corresponding numerical question. Finally, derivation part. Okay, based on this CD, let us have some questions. Come on. A coil is tuned to. It is not turned to, it is tuned to. A coil is tuned to resonance, right? What is the first thing? F1, 500 kilohertz. C1, what is that? 36 picofarad. He has mentioned clearly a coil is tuned to a resonance of 500 kilohertz with a resonating capacitance of 36 pico. Second step, at 250 hertz means frequency change first. The resonance is obtained with a resonating capacitance of 160 pico. So therefore, F2 is 250 kilohertz and C2 is 160 picofarad. What is the self capacitance of the coil CD? Direct answer. C1 minus N square C2 by N square minus 1. Direct formula substitution. Tell me. Yes, 5.33. Why means with respect to this, we need to understand N is equal to F2 by F1. That is, what is it? F2 by F1 is 1 by 2. So you'll be getting 5.33 picofarad. Got it? So answer is 5.33. (16 by 3), correct. Right? Now, take this question as the homework question. In this, two questions I'm giving. One is distributed capacitance calculation, self-inductance of the coil calculation. Distributed capacitance and self-inductance. Right? Take this as a homework. Simple question already we have done. Inductance formula is there as well as what is it? CD formula is also there. Clear? Let me take one more question. The basic principle of operation of Q meter is based on the property of series resonance circuit. Yes. So what is the answer now? Assertion is true. Assertion is true. Reason: if a fixed voltage is applied to a series resonance circuit, if a fixed voltage is applied to a series resonance circuit, the voltage developed across its capacitor is Q times the applied voltage. So what do you mean by this? This is what people are getting confused. Fixed voltage applied means for a given voltage, for a given input voltage, automatically what is it? The voltage across the capacitor is quality factor times the supply voltage. Yes, reason is also true. Clear, guys? Assertion is true and reason is also true. Right. Mukul Jagtap. Why second option? Why reason is wrong? You may be getting confused here. What is the meaning of this? Q is, what is it? VC is equal to Q times of supply voltage, means for a particular voltage is quality factor times of this voltage is voltage across the capacitor. Of course, for that particular voltage into quality factor is equal to VC. That's what the question. So therefore, this statement is true only. Clear, Mukul Jagtap? Yeah, that's what fixed voltage means. For a given voltage, of course, definitely for a given operated voltage only we give. So that's why, yes, for a given voltage. Okay, now tell me, reason is giving the correct explanation of assertion or not? Come on, option A or option B? Option A only. Why? If the reason is clear, then only we can understand that, okay, resonance is occurred. So therefore, resonance condition itself is quality factor times the supply voltage is equal to voltage across capacitor. Therefore, yes, both are correct and reason is the correct explanation of assertion. So option A. Of course, many people give the correct answer. Right, next question. Do this. The true value of quality factor of the coil is 245. Measured value is 244.5. Then the ratio of resonating capacitance in Q meter circuit to distributed capacitance of the coil is dash. Right, make it. Already gave the formula. What is it? Q true by Qm is equal to 1 plus CD by C. I gave the derivation. I'm giving the formula directly. Find out and tell me. Come on. Okay, Gurudatta Behra gave the correct answer. Others? Option B, option C, option A. Your people are covering all options. Come on. This is what the problem. See, if you simplify this, you are going to get, if you simplify this, you are going to get CD by C value is approximately 0.002. People are saying this as the answer. No. What he is asking, then the ratio of resonating capacitance in Q meter to distributed. So therefore, he is asking C by CD, you will be getting 489. This is not the answer, but to confuse you, first option is given. That's what he's asking here. C by CD, not CD by C. So answer is yes, option C. Clear? All right. Next, last question in this. This also already I gave the derivation. What is it he's asking? Q true is equal to observed Q means Q measured into dash. Already gave the derivation. Let us go back and see that here. I gave you this one. Q true equal to Q measured into 1 plus R by R coil. 1 plus R by R coil. Okay. 1 plus R by R coil. But in the question, terminology is in a Q meter, if a small resistance R is added to the series circuit to inject the oscillatory voltage, of course, R is R only. QM into 1 plus R. Okay. But to confuse you, he has given that RS is the apparent series resistance, means the apparent series resistance means the coil resistance which is connected from outside. So in the place of coil, we have to keep RS. That's it. This is what the answer. But if you see the options, all are looking like 1 plus R by S, 1 plus R by S. But here, 1 by 1 by 1 by 1 plus R by RS. 1 plus R by RS. So option B. This is the smallest chapter, Q meter. Yes, option B. Clear? Now I'm stopping now. Let us have the doubt session. Tomorrow we'll be continuing CRO chapter. After that, some miscellaneous topics I will be taking. Right. If any doubts are there, kindly talk to me. Yes, Sai Charan Reddy.
Sir, I'll ask afterwards, sir.
Yeah, Anil Kumar.
32F, sir.
32F. Yeah. What's your doubt?
Sorry, this diagram, you have explained that how to find that resonance place while varying the tuning capacitor and oscillator.
I didn't understand
you.
your doubt.
Explain it again.
Yeah. Okay. Got it.
Sir,
see, I got it. Yeah. By varying the tuning capacitance and by varying the oscillator frequency, observe the magnified voltage across the capacitor. Observe the amplified voltage across the capacitor. Once the voltage is amplified, stop varying that. At the time, note the voltage, that is amplified voltage, and input voltage. That's it. VC by VI. That's why very keen observation is required. You cannot vary like that simply by varying that voltage across the capacitor must be observed very much keenly. Then note down what is that highly magnified, highly amplified voltage. Clear?
Sir, clear. Sir, next slide, sir. Can you please explain that how to write the true value and measured value, sir?
What is a true value, measured value? True value means actual value. Actual value by actual value. Here, measured value means this is the measured value from the circuit. In the circuit, what is the frequency? Omega only. What is the inductance in the entire circuit? L coil only. But what is the resistance in the circuit? Not only R coil, R plus R coil. Simple logic. True means only coil related. Measured means in the circuit, whatever the elements are that you have to take. Here also, circuit frequency, total circuit resistance, total circuit capacitance. That is, circuit means measured value. But sir, true value means, right, coil actual resistance. But along with that, C and omega commonly being taken. That's what the point. Clear?
Yes, sir. Clear, sir. Thank you, sir.
Right. The moment your answer is done, kindly lower your hand, kindly everyone, so that I can allow other person to speak.
Hello, sir.
Yeah.
Sir, 24F, sir.
24F.
Sir, here you have said that according to formula, I got the resolution of 0.1 millivolt, sir.
Yeah.
Sir,
Second
but
formula you have to do it.
yes, sir.
Yeah.
Sir, but when you said that if you add half digit and without adding half digit also, the resolution is same, no, sir? Means how practically resolution is varying, sir?
Practically does not vary. No resolution, how it is varying? Where did I say varying? It is not varying.
Means 3.5 digit voltmeter should be a same resolution, no, sir?
Yeah, same resolution.
Means how we are getting as 0.1, sir, millivolt.
Okay. You got that doubt. Okay, I got it. See, 200 millivolt full scale is possible. First of all, you are missing that. Actually, in the 3 or 3 and a very good question. 1 volt, 1 and 2 volt is a minimum. Okay.
Yes,
10
sir.
volt, 10 volt and 20 volt is a minimum. But in the question, to confuse you, to kill your time, 200 millivolt means what is the value? 0.2. So 2 itself is the minimum. How the 0.2 is getting? Practically no. But for this question, this is the answer. Good question. But practically 1 volt is a minimum. Correspondingly, 2 volts is the minimum extended range. But in this question, he has given that 0.1 volt is given. So 0.1 volt full scale, how is it possible? No, that's why numerical question based answer. Very good.
Yes, sir. Yes, sir.
Very
Okay,
nice,
sir.
very
So
nice,
it means in practical we have only for 3.5 1 millivolt only,
Yeah.
sir.
Yes, correct.
Sir, okay, sir. Sir, 21F, sir.
It's always know the concept and according to the question, give the answer. Okay.
Sir, here,
Yes.
sir, what is the actual meaning of that sensitivity? That means it is responding for a small change of 0.01 millivolt, sir.
Yes, that's what.
Sir, but how that formula? Can you explain how that formula?
Formula, there is a concept based only. If the concept is, if the derivation is there, any expression is, I would have given, but directly formula given directly. What is it? Full scale minimum resolution. By the concept only it is given. Don't worry.
Okay, sir. Sir, last one, sir. Sir, for a 3.5 digit, when you keep the switch at C position, we are saying that range is 200 volts, no, sir?
Yeah.
Sir, but the maximum voltage should be 199.9, no, sir?
Yes.
Sir, means how 200? That means it cannot show 200, no, sir?
Then what is the answer for this? I gave clearly in yesterday's class. 20 volts range means up to 20, not exactly 20, 19.99. Are you clear?
Okay, sir. Yes, sir.
Same
Yes,
thing.
sir.
Switch B, switch is same thing.
Okay, sir. And sir, if we give exactly 20 volts, then output is 9 watts at 0.00. That
Actually, exactly 20 means actually practically, do you get exact value?
Sir, if I know that
No.
20 volts.
First you tell me, do you have any exact value practical world? Definitely tolerance will be there, no?
Yes, sir.
That's what, no question of exact value. In the question itself, answer is there.
Okay, sir.
Right.
Okay, sir. Thank you, sir.
Right.
Hello, sir.
Yeah. Who is this?
Sir, Sai Charan Reddy, sir.
Yeah.
Sir, in that 4.5 digits DVM, sir.
Yeah.
That 10 counts and 0.2 of reading.
You're talking about question?
Yes, sir. Question only, sir.
This one?
Sir, in that 0.2% of reading and 10 counts, that error.
Okay. 2 marks model question. Yeah. Tell me.
Sir, in this we are taking here true value is not given, and that readed value we took true
First of
value.
all, Sai Charan Reddy, I remembered your name. Did you attend my electrical measurements class?
Yes, sir. Attended all
Yeah,
classes.
go back to that videos and get it clarified. Because I told
Sir,
many a times about this.
Sir, but in this question,
That's what
he
I
told
told you.
that error is there.
That's what I told you. Go back to the earlier electrical measurements class, and I told that I have taken the questions also. You only asked that. I remembered, sir, red value is given. How can you take the true value means? I give the clear-cut explanation. If you're asking same thing means you have not studied the entire electrical measurements, is it?
Sir,
If I
not
say
like
like
that,
this,
sir.
don't, if I say, if,
This topic is different. I am getting that doubt again.
why?
Sir.
Reading is reading only, right? Reading is reading anyway. I told the universal rule in the given question. If the red value is given, shown value is given, but according to the data, if we require the true value and the true value is not given, then red value is to be taken as a true value. I gave clearly. Topic is different, but concept is same here. See, if I say like this, don't take it to heart and don't feel bad. Intentionally, I'm saying, because you answer every question clearly, I know, but you should not miss this small word. That's why I'm saying that go back and read that. But I explained already, just now also explained. If any data is given like this, yes, red value is to be treated as true value. Otherwise, there is no procedure.
Yes, sir. I understood that assumption, sir, but
Not assumption. Take it for
here
granted.
2% of 0.2% of reading means here 0.2% of 100 volts we took.
Yeah.
But here 100 volts is true value or rated value.
That's what I told you. According to this reading you take, according to the true value what we require, you need to take true value. You are not understanding my statement. Again, reading gave clearly, no confusion in this. 0.2% of 100 volt. But after that, we need to have the true value, but true value is not given. We cannot get directly also. That's why, what is it? Whatever the shown value, whatever the true value, yes, both are almost in that way. 100 must be taken as true value also.
Okay, sir. Yes, sir. Understood.
Yes.
Sir, in that full scale value minimum.
Sensitivity formula?
Yes, sir. Sensitivity formula.
Yeah.
Full scale value minimum.
Yeah. What's your doubt?
Sir, here full scale value minimum is not equal to like minimum value measurable, sir.
Full scale, what do you mean full scale? Is it measurable value or scale range?
Scale range, sir.
Then
total scale range.
Then no, you elaborate your doubt. I'll clarify.
Sir, when
you're asking one thing, so full scale minimum is not the minimum measurable value that is measurable. This is full scale. How can you say both are same? And I told you also. That's why when I'm explaining, kindly listen carefully. 3 digit 1 volt, 3.5 digit 1 volt 2 volt. Here 10 volt, 100 volt, 10 volt, 20 volt. 100 volt, 200 volt. If I'm taking like this, which is the smallest measurable, which is the smallest full scale value? 1
volt.
If
yes,
I'm taking this one, which is the smallest full scale value, this that you have to take.
1
That's
volt.
it.
Yes.
I told you already in the class. Also I told you.
Okay, sir.
Right.
Sir?
Yeah.
Sir, can you open the switch A, switch B slide, sir?
3.5.
Switch
Yes.
A, switch B
Yeah.
slide once,
Yeah.
okay, sir.
Yeah.
Sir, ikkada manamu 0.999 volts of off digit S switch on అని అంటున్నాం కదా సార్. అదే స్విచ్ బి ఆన్ చేసినప్పుడు 0.999 అలా ఎందుకు తీసుకుంటున్నాం సార్?
మీరు మిస్ అయిపోయారు, టోటల్ టాపిక్ వినలేదన్నమాట. అవునా? చూడండి ఇక్కడ స్విచ్ ఏ, కైండ్లీ కాన్సంట్రేట్. యుగశ్రీ, see here. స్విచ్ ఏ అంటే డెసిమల్ పాయింట్ ఎక్కడ వస్తుందమ్మా?
0.9.
అంటే ఏంటి? 0.999. ఓకే.
ఓకే.
స్విచ్ బి అంటే ఇక్కడ.
00.
అందుకే నేను క్లియర్ గా చెప్పాను ఏంటంటే, స్విచ్ ఏ ఉన్నప్పుడు డెసిమల్ పాయింట్ ఒక దగ్గర ఉంటుంది, స్విచ్ బి రాగానే డెసిమల్ పాయింట్ మారుతుంది, స్విచ్ సి మళ్ళీ ఇక్కడికి వచ్చేస్తుంది. అంటే ఇక్కడ ఏమొస్తుంది మనకి 0.99 పాయింట్. అందుకనే స్విచ్ సి అనేది జస్ట్ మూవ్ చేయట్లేదు మనము, బేస్డ్ ఆన్ ద స్విచ్ పొజిషన్ మూమెంట్ ద డెసిమల్ పాయింట్ ఈస్ ఆల్సో గెటింగ్, దెన్ ఓన్లీ వి కెన్ సే ద వాల్యూ విల్ బి చేంజ్ అప్ టు 1, అప్ టు 10, అప్ టు 100. క్లియర్?
ఓకే సార్. సో ఇది 4/1/2 ది వాల్యూ వచ్చేసి 1,999 అని అన్నారు కదా సార్?
4.5.
ఎస్ సార్,
149
అని అన్నారు కదా సార్?
999 కాదమ్మా, 149.
4 9s అన్నారు కదా సార్? ఒకవేళ 4 డిజిట్ కే అయితే 0 వస్తుందా సార్ 1 ప్లేస్ లో?
ఇక్కడ చూడండి అమ్మా, 4 డిజిట్ కదా,
ఓన్లీ 4 9s.
ఓన్లీ 4 9s. 4 డిజిట్ కి ఓన్లీ 4 9.
ఓకే సార్. 0,999 అనే దానికి రేంజ్ తీసుకుంటామా లేకపోతే?
మీ డౌట్ ఏంటి? క్లియర్ గా 4 డిజిట్ డిబిఎమా, 4.5 డిజిట్ డిబిఎమా?
4. ఇప్పుడు దీనికి రేంజ్ ఇంకా రెజల్యూషన్ అనేది, సెన్సిటివిటీ అనేది వేరే బుక్ లో నేను చూసాను సార్. అయితే 0,999, 0,499 అనేది చూసారు. అది
క్వశ్చన్ అర్థం కావట్లేదు ఏంటమ్మా? రేంజ్ అనేది ఏంటి?
రేంజ్ రెవల్యూషన్ అనేది క్వశ్చన్స్ ఇస్తా ఉంటాడు కదా సార్, 3/1/2 కి రేంజ్ ఆఫ్ డిజిటల్ మల్టీమీటర్ అని అలా ఇస్తున్నప్పుడు 0,999 అనేది, 0,499 అనేది ఎప్పుడు యూజ్ చేస్తామని అడుగుతున్నాను సార్.
0,999 అనేది ఎప్పుడు యూజ్ చేస్తామా? క్వశ్చన్ పంపించండి అమ్మా ఒకసారి. నాకు క్వశ్చన్ పంపించండి, ఆ నెంబర్కి నేను చెప్తాను ఆ క్వశ్చన్ ఎక్కడ చూసారు ఏంటి.
నేను వెతికి చెప్తాను సార్.
యా ఓకే. ఇంకొకటి, see those who are on the line with this student Yugashri doubt, I am getting one more point where you are getting stuck. Simple logic, whatever the thing you have taken 3 digit, concentrate here. Other people also, as I'm revising this point here, 3 digit means this one. Okay, it will go up to 999 is the range. Okay, if I give 55, it will show 55 only like this. Okay, if I give 75, suppose if I give 75, it will show 75 like this. Okay, suppose if I go for switch A position, decimal point will be like this, right? I am not saying that this will be shown, no yeah, this will be the maximum allowed capacity. Suppose if I give 0.65, yes, it will show 0.650. Okay, if I give 0.95, it will show 0.95. After that 0, no problem, no value at all. Okay, 0.00 switch B position is there, it can read up to 9.99. I'm not saying that always 9.99, no, I told you up to, that's why maximum. Suppose if I give 1.75, it will show happily 1.75. If I give 2.35, it will show happily 2.35 like that. You guys see, is it clear?
Okay sir.
Right,
Sir,
these values are capacity values only, not measured values. Okay, now tell me.
Sir, last problem lo QT true value by measured value equal to 1 plus
CD by C.
C kada sir. Sir, 245 by 244.5 minus 1 తీస్తే 0.22.
Yeah,
sir,
CD by C is
0.00.
equal to 245 by 244.5 minus 1. If you substitute this, you will be getting 0.0019 or 0.002 something you will be getting approximately. Check it once. That's why I gave you here. It is not exact, of course, approximate. If you simplify that, you will be getting C by CD because he is asking C by CD.
Yes, sir. C by CD చేసినా కానీ 500 వస్తుంది సార్, అందుకనేసి
ఫైనల్ రాదమ్మా, అంటే ఇక్కడ ఎగ్జాక్ట్ రాదు. ఇక్కడ మీకు 21 సంథింగ్ వస్తుంది. ఒకసారి క్యాలిక్యులేట్ చేసి చూడండి. 245 by 244.5 minus 1 0.002 ఎగ్జాక్ట్ రాదు, 0.0022 సంథింగ్. దాని తర్వాత 489 అప్రాక్సిమేట్. అది ఫైనల్ అప్రాక్సిమేట్ అనమాట, నాట్ ఎగ్జాక్ట్లీ.
సార్ ఇప్పుడు క్వశ్చన్ అంటే చేంజెస్ ఇచ్చినప్పుడు మనం ఐడెంటిఫై సడన్ గా ఇట్లా ఈ క్వశ్చన్ కి ఇట్లా ఐడెంటిఫై C by CD అని CD by C అని ఎలా ఎప్పుడు తీసుకోవాలి?
లేదమ్మా, ఫార్ములాలో CD by C నే. బట్ ఇక్కడ క్వశ్చన్ ఇక్కడ చూడండి, క్వశ్చన్ జాగ్రత్త చదివితే రేషియో ఆఫ్ రెజొనేటింగ్ కెపాసిటెన్స్ ఇన్ క్యూ మీటర్ సర్క్యూట్ టు డిస్ట్రిబ్యూటెడ్. క్వశ్చన్ ఏం అడుగుతున్నారంటే రెజొనేటింగ్ కెపాసిటెన్స్ కి డిస్ట్రిబ్యూటెడ్ కెపాసిటెన్స్ కి రేషియో అడుగుతున్నారు వాళ్ళు. అది పాయింట్ ఇక్కడ. నేనేం మార్చలేదు, CD by C నే ఫార్ములాలో ఎప్పుడైనా సరే CD by C నే. కాకపోతే క్వశ్చన్ ఏమడిగారు, మిమ్మల్ని కన్ఫ్యూజ్ చేయడానికి C by CD అడిగారు, CD by C అడగలేదు. అది పాయింట్. ఓకేనా?
ఓకే సార్.
Hello, sir. Good evening, sir.
Yeah, Shiva, right. Tell me.
Yeah, sir. Once explain the formation of stray capacitance.
Which one?
Stray capacitance.
Huh?
No, sir. Stray capacitance.
Yeah. What should I explain?
No, the formation of stray capacitance, sir, in Q meters.
Formation of capacitance in Q meter. Yeah, this one.
Yes, sir.
Yeah, simple. Every element which is coming from outside will have its own capacitance. That is stray capacitance from this terminal to this terminal. But effect will be taken in the basic electrical engineering point of view. Always, whatever the capacitance is formed due to the external cases, that will be taken in parallel with the inside capacitance. That's it. Simply, this formation, how it is formed means this is coming from external side. This is coming from external. That is stray capacitance due to the external condition. Of course, this is coming from external. Therefore, it has its own self capacitance. But generally in the network theory or somewhere else, you neglect this. But in our case, we are taking. After that, according to the principles involved so far in the practical scenario, practical world, external capacitance is always parallel with the tuning capacitance. But we cannot draw like this. We cannot draw. But concept says that it is coming in parallel with this. That's it.
Okay, sir. Then, like whatever the inductor or coil we are connecting the circuit, it will have its own stray capacitance.
Very good. Yes, that's why
yes.
Based on its own nature, that CD will be changing. That's it.
Yes, sir. Okay, sir.
That's why I told you. L coil is unknown, CD is unknown. So therefore, both are depending from coming outside. Yes, good.
Okay, sir. Yes, thank you, sir. That's it.
Right.
Hello, sir.
Avinash, yeah.
Hello, sir.
Yeah, tell me.
Sir, in a 3.5 digit DVM, sir, the half digit switch, when it will how it will automatically turn on, sir?
How it automatically turn on? Very good question. See, if you give, as I told you, if the number is there 0,999, okay. But suppose if I am giving the clock pulse, means some input is given. This input is producing the clock pulses, 1000 clock pulses, for example. So 1000 clock pulses means what is it? Here, this number is 999 was there. Means 999 clock pulses, this value is there. But now our input produces the 1000 clock pulses. Then this 1000th clock pulse means what is it here? One more clock pulse is coming means 9 is there plus 1, 10. Okay. Now carry pulse. 9 is there. Okay. Already plus 1, 10. Again carry pulse means it will be driving. 9 is 10. Now this carry pulse will give the trigger pulse to the corresponding flip-flop. Then 0 becomes 1. That's why I told you, based on the given input, suppose if I'm giving the input says that 450 clock pulses only, therefore it will show 0, 4, 5, 0. Suppose if I'm giving the input such that it is producing more than the 1000 clock pulse, or approximately equal to 1000 clock pulses, then we can say simply the toggle flip-flop will be activated. That's what the point.
Okay, okay.
Clear?
Clear, sir. And sir, in a 3-digit DVM,
Yeah.
yesterday's class, sir.
Yeah.
Sir, in this circuit, sir, this 5-volt switch here, which is here, sir, ABC, we have selected here.
Yeah.
Whether it is automatic or it is selected by manually.
No, inbuilt by battery, one cell we can, I told yesterday, with one cell it is there already. So automatically it is connected. This is internal, battery based.
Sir, means it is automatic process. It will shift from A to B and B to C.
See, all I told you clearly 3-4 times. If we change, today also I told you, if we change the range selector switch to A, it will move to A. I told you clearly in this class, both are interlinked internally. Don't say automatic. If we keep the range selector switch at A, it will move to A. But don't say automatic means without this scenario, it will move. No, with this movement, it will be moving. So that's why I told you yesterday class, range selector switch is operated by the operator, but the internal switch will be moving according to the range selector switch position. Clear?
Okay. Yes.
Right. Next, Swain.
Hello, sir.
Yeah.
Sir, sensitivity is equals to full scale minimum value into resolution.
Yeah.
Okay. Then the resolution actually is varying according to switch position.
Yes.
Resolution is varying according to switch position.
Definitely.
Then we are calculating for full scale minimum, means for 1 volt. Let's suppose, as you say, 1 volt or that.
Yes.
Means what is its physical, means technical?
Very good. Very good. Very good. Yes. See, if I say about full scale minimum 1 volt, corresponding to 1 volt resolution only is to be taken. You are missing something. Okay. If I'm talking about full scale minimum 1 volt for a given device, for example, 3 or 3.5, corresponding to that resolution only will be given. Otherwise, suppose if he is treating like 10 volt in his data, suppose he is saying that full scale minimum is 10 volt according to the given data, 10 volt related resolution only to be taken. That's always correspondingly taken, not
Okay.
universally. Good question.
Okay. Thank
Clear?
you. Thank you. Thank you.
Right. Let all raised hands down. Okay, right. Now I'm closing the session. We'll meet tomorrow. Right. Can give your mobile number. Right. So this is my mobile number. And people are asking that, sir, upload the notes as quick as possible. Already I told him. And this is the corresponding person number, because he will upload actually. Few people asked me, so I gave the number. This is the manager number. You can talk to him regarding uploading, because uploading is not in my hand, but be clear. People left the class. I need to announce the session actually, tomorrow's schedule. He is the manager. Yes, he will be taking. His name is Seshu. And
Sir, announce the class, sir.
Yeah, I'm announcing the class. See, tomorrow's class is, concentrate, 6:30 a.m. to 9 a.m. Signals for whom? Only regular batch. Only regular batch. Okay. And as usual, 5 p.m. to 9 p.m. my measurements class. Measurements class for all students. Regular batch and morning batch and evening batch, means it includes all. as usual. This is the schedule for tomorrow's. Clear? Right, this is the person number regarding uploading. He will take care actually. That is not in my hand. After the class, immediately I will send the file to him. He will upload. Okay. Right. Thank you. We'll meet tomorrow. Right. Thank you.